Welcome, and today we have the wonderful Char Stiles back. We are
Back with
so
us again.
happy.
Yeah.
I'm so happy to be here. This is my favorite Twitch stream ever.
Really?
It might be my favorite thing in general.
Aw. Yay. No, we're really excited to have you back, especially because you come bearing, I guess, a refreshed version of Shader Plays, because it was like alpha last time, no?
Yeah, it's still pretty. I haven't changed like the way that it renders, and so hopefully we won't run into the same issues that we ran into last time. I was planning on doing that, but then, I was working on other stuff.
Yeah.
Yeah.
It happens.
But Shader Plays it's gone through a bit of a change, and then I changed it back, and then I added more differences. But I'm so excited that Ilithya and Andrew created Shader Plays' first pull request. Oh my gosh, that made me so happy. Like made my life. Because it's like I'm making this thing and like I'm like, okay, I hope people like it, I hope people will use it. And the fact that y'all were like, oh, I would like to have this feature for us to use it, fills me with joy. And so I pulled that in today, and we're not going to see the changes in this, but it just like if you were to go to Shader Place, you can see that there's two different options. You can say like editor or present, and like editor is like it has the code side by side, and present has the code in back, so it's like easier to read.
We were just having that conversation before we went live and before you even joined us, because I love having the code on top of it, but Eliza hates it. She finds it too distracting.
I can. I was telling Eliza that maybe I'm old. That for me it's just that I just cannot read, and especially depending on the shader, right? Because maybe I have a shader that is not visually too noisy, but if I'm doing something that it has a lot of noise and color, which most likely I'm doing, then I cannot read the text. So then I prefer like to separate. But I was telling Liza, I understand like if I would be performing, then it's cool to put the code on top of what you're doing. But if I'm just sitting alone, like here, just experimenting on my own, I prefer like to split it separately. That's what I meant, like when I'm just like studying or exploring stuff on my own. So it was nice.
And so for those, sorry, go ahead.
No, I just wanted to mention that the PR that we sent, most of the credit goes to Andrew because he did almost everything. So I just helped with a little CSS. So if he's around,
CSS is it's another thing. I was playing with the CSS before this, and I was like, I wish I had Ilithya here.
But we're happy that you like the suggestion, and because you made a great tool. So. For shaders.
And so for those who don't know, we are in Shader Place right now, and you can see like my mouse is on line 22 right now, and I can slow down. I can change this number 5 to be like 1, and then time will move faster, and it's like a Google Doc for shaders. So it like updates. Yeah. And so. Yeah, that's just like the gist of it. It's a collaborative.
You said before that your scroll stopped working, but it works for me. Or I guess.
Oh, that's for the other one. That's for the.
Okay, my bad. Cool.
Yeah.
The editor mode, I believe, right? So.
Yeah.
Can we share the link of Shader Plays, by the way, Char, at the moment, or do you prefer that we share at the end?
No, she put it in the.
Okay.
Oh,
good.
yeah.
Because somebody was asking for it.
Yeah, anyone can use Shader Plays.
What was your remind me what your motivation was for building a shader editor?
Oh yeah.
Originally.
So I teach shader workshops.
This is how we met.
Exactly. And I teach them mostly online, and teaching it over Zoom is really difficult because your frame rate and your resolution gets like demolished by Zoom. And
true.
I was like, okay, but I can just send the code. Like the code is less information than the image that it produces. So if you just send that over, then it's like, what is it? The ultimate lossless like compression ever. And so I was like, if we just send over the code, then, you can render that locally, and the student can see the beautiful shader rendering locally on their machine. And then it also allows for students to like collaborate on shaders together, which is something that I really like.
I love
missed.
That.
Yeah. Them being able to like check in with each other, because especially because when you're learning shaders, like it's hard. It's hard, and like you need to like be able to like kind of, if you wanted to like check yourself, I know. If you wanted to like check yourself with other people and be like, are you like, does this thing make sense? And then, oh, like I'm also not getting that. And then it's like, or you help each other and stuff like that.
I agree, because sometimes it's too hard if you're just sharing your screen, like let's say that you're like kind of like studying with someone, and then you share your screen and you're coding and the other person is suggesting something, but it's just not the same feeling of if both of you are actually
in the editor,
like exactly
poking together.
Especially when you're doing it remote too, that you cannot be with the person maybe sitting there with you in the computer, right? So then it's it's nice.
But yeah, I'm super happy that it's like, I mean, it's like barely functioning, but it's been working for classes. I have students go together and make stuff in the rooms together.
That's
and
so
it's been
fun. Yeah. Okay, so you've been able to test it out in situ. That's good.
Yeah.
It's definitely more than barely working that. Give yourself some credit.
Yeah, I guess I just feel like it could be so much more,
Oh, but that's all.
That's for the future. Yeah.
It's a working process, and now like we started like teasing with like some suggestions, so maybe other people will send PRs, or maybe you will find the time as well to go back to it.
Yes. Yes. Exciting.
Okay.
Should I talk about what we're thinking about doing today?
Yeah, definitely.
Yeah,
so
since
last week we did like a base introduction to shaders with Dan, which was super fun. We thought today, since you're so wonderful at raymarching, we would kind of go over raymarching basics. Build one from scratch instead of diving into craziness right away.
I love that so much, because that was what made me like get hooked. I was like, you're just using like a 2D screen and you're using like linear algebra to pretend that it's 3D, and it just works. Like that's amazing. And I was also thinking, if we have time, another thing I wanted to, like, if we get through like the raymarcher quickly, I recently did an interview. I did a coding interview, and they asked me to write a lookAt function.
Ooh.
And because of right? And I was, this is something that I learned for like to teach my students in workshops, and then I was able to like use it in real life.
Awesome.
Not that it's teaching in real life, but like I was able to like use it in that. So I was like, we could write the lookAt function too if we have time, because that's always really fun.
Oh, I would love to.
Yeah, I would love to.
Let's try for that.
Yeah, I would love to see that, Char. Yeah, definitely.
Cool.
Yay.
So, okay.
Yeah.
Let's do it. So I guess we get rid of the 2D stuff.
Can you hear the vacuuming?
No.
No.
Definitely not. Can anyone hear the traffic outside?
No.
No one can hear the
I think like
honking?
sounds
Okay,
are like, since we're all with mics, I think it's fine. Like we don't see this, hear this background sound.
Good. No. Awesome. Oh, Leah. Hey, Leah. Yay. Cool. Okay, so let's do this. Let's get rid of, I guess I will get rid of everything but color.
Yeah.
Should we keep the
and
UV?
Then, I think we keep UV. So the first thing that we're going to have
keep
to
the time
do,
to it just in case.
Yeah.
Yeah, we'll keep time. The first thing that I want to do is we need to start pretending that everything's 3D. And so we just say vec3 cam position vec3, and then let's just have it be like 0, 0, -1. And then, do you know what's next?
You need your cam position, you need your you need
the field of
the what?
Field of view.
The field of view. Yeah. That's your distance to the screen. No?
We can do field of view when we write the lookAt function.
Yeah.
Oh, okay.
Yeah, so we'll go to that. We'll have that later. But the bare bones, we need a camera position and a direction.
Yeah, is that your
camera position and then
view ray, I guess?
Yeah.
Is that the word? I don't know. The little arrow.
Oh, we need ray. So we need camera origin, ray origin, and then direction. That's all we need right now. And also, like, we could use target, but I think we'll get to that later.
We could use
Okay.
what?
Target.
We're going to use target when we do the look at.
Okay, cool. Wait, I moved my second headphone in.
Maybe I should give like a little primer to like what raymarching is in general. Also, someone asked what shader place is. Oh, it's the shader environment Char is built for co-coding. Yes, that's exactly what it is. Thank you.
Yeah, do you feel
like Cookie says, ray direction, ray origin. Yeah, I guess we could maybe explain what raymarching is. It's like, you can. I'll let you do it.
No, you please.
You'll be more succinct than me. Oh my God, no, I won't explain it well.
Oh no, my computer is freezing. Can you still hear me?
Oh no.
Can people still hear us?
Oh no.
People,
shader
can you hear us?
This is the same.
Shit.
I don't think so. You look frozen. Maybe should we just use?
Hold on a second, because I don't see you like in the videos. You're frozen. I think our voice maybe they can hear us, because thankfully I'm from. I think they can hear us, right? So, can they?
I don't know.
Oh, my whole computer froze.
Oh no, I'm so sorry.
Okay, people can hear. Oh, hey, Sean. They can hear us.
Okay, I imagine that.
Can you see us, though?
I think so, because I can still hear us.
All right.
No, they cannot see us because everything is frozen on my end.
Oh, you're frozen for me too now. Oh, so are you? No, you're not sure.
Oh,
but ilithya for me is frozen. Yeah. Okay.
Yeah,
sorry, guys. We'll be back in a sec, probably. Just hold tight.
Oh, my computer.
I mean, whenever I think of raymarching, to explain it, I just think of a giant circle that like it appears on like there's like an arrow that shoots out, and then there's like the circle, right? And you like hit the object, and then the circles get littler and littler as you like creep towards the edge of whatever the object is. But I don't feel like that's a very succinct explanation.
I think that's great. I think that's exactly what it evokes for me too, like the imagery.
This is so...
Like when I think of raymarching.
Okay, cool. As long as it makes sense. I mean, I think that's how I had a hard time putting what I visualize into like actual proper sensical terms for people. But if it makes sense to you, then I feel like I'm on the right track. Video is frozen. Yeah. Okay. I think we just lost ilithya, so we're probably...
I'm here, but it's just my computer. I cannot move.
I guess we're offline, because if she's off...
I cannot move.
Then we must be offline.
You can still hear me, right?
I love our group of people.
I can
you still hear me?
Oh, Eliza, can you hear ilithya?
No.
Okay, so I have ilithya through Discord, and I can hear ilithya through Discord.
Yeah, because on Discord I can hear you
crazy.
both.
I don't have.
I can hear you both.
Ilithya, but I don't.
I can hear you both, but you're listening to me through Discord, right,
But
Char?
I see that her thing is green, so she must be speaking. Why can't I hear you?
Because maybe you're listening the meet, Eliza. I think you're.
Discord.
You need to mute.
I muted myself. I unmuted myself.
I mean, once we get back on the
we're back, but I'm afraid, and I forgot that this happened last time. That I'm afraid that it might happen again, but we can try and see.
It did happen last time.
It happened. It crashed a few times, so we can just wait and see. We're back.
Okay.
Yeah, I wonder why. I have to figure out.
Yeah, me too. There must be something.
No, I think it's shader place, because it's like, it's kind of like I just make like a Three.js context, and then I just display that without, I'm sure there's like ways that I can optimize it.
I feel like it's maybe shader place plus the stream though. It's not like, you know what I mean? There's probably just like a lot happening. I don't know.
Yeah.
Because for you it doesn't happen, right? Like it doesn't crash for you at all. And I think I tried when I was trying it as well, like for example with Andrew, it didn't crash. So I'm assuming it crashes because at this very moment I have like OBS, I have shader, like my computer is reading all this stuff. So then maybe at that point, then the GPU or something is like too much.
Yeah. Okay.
That makes sense.
But we can try.
I'll make an issue.
Anyways, if it crashes again and it's annoying, we can always jump to an editor. I think it's fun to use Char's editor.
I think so too. So we should try.
I appreciate it. I mean, we could try like one more time.
Okay, I think we're back. Yeah, everyone can see us. I can see us. Hi, sorry guys.
Hi.
It happens.
Yes.
Remember, we're live, so.
Yes.
Yeah.
The perils of the job.
So you were saying
we were
you
talking
wanted to explain raymarching, right? You said like for some people that maybe that are here that are not aware of what that is, which that's a great idea.
You still want me to explain my circles analogy? I don't know if we were offline or online when I said that. But for me, raymarching is just like there's a camera and it shoots out a little arrow. Like I guess that's the ray. And if it hits something, then there's like a little circle that traces around it. I'm not sure why, though. I don't get that part. But then it hits the closest part of the object, even though that's not what you're aiming to hit. So until you hit what you're trying to hit, the circles will keep appearing smaller and smaller and smaller until you get to the final destination, or until it doesn't hit anything and you've maxed out your steps.
Exactly. Yes. Yeah. So also like raymarching, for those who are just coming from like maybe like the 2D shader tutorial, it's a way to create 3D in a 2D shader using linear algebra. You basically just like kind of add a third dimension, and then you start pretending like your screen is casting rays of pixels into the scene that you create. And then that's where the circles come in. And the circles come in, they are representing signed distance function. And that's the black magic of raymarching. Yes.
Yeah.
And the signed distance functions are these kind of like ways of describing shapes by returning the distance of the surface of the shape, to your point in space. And so like that's why it's a circle, because like if I return a distance of a point right here in space to my face, I will return something like, 1.5 feet. But the truth is that when it returns 1.5 feet, it doesn't know which direction it's going in.
Yeah.
It could be 1.5 feet this way, and that's where the circle comes in. And that's why it's like spheres that come through.
It's true. There's no direction or whatever, orientation, right, in a raymarching.
Yeah. So it's very much like the just this kind of math like works out in such that like you can define shapes by using SDFs, that there's no direction, and that's why there's like circles. And that's why you also call it raymarching, because there's no direction. You have to march along the ray. It's also called sphere tracing.
Yes.
I read some notes that I wrote the other day, and it was like, it's also called sphere tracing. It's also called like ray crawling. It's this way. The reason it's like this is because graphics programmers don't talk to each other enough, and then they all like
because there's also ray tracing, but ray tracing and sphere tracing are not the same.
They're different. They have like similar concepts in that they follow like a ray through space, but the mechanisms are different.
Cool. Okay. And so to create a raymarcher, we need to create a camera. So for a camera, we need the position of the camera and the direction it's pointing in, I guess.
Yes, we need the ray origin. So the ray origin.
Yes. Oh wait, we already have vec3.
Oh, sorry. Origin equals, and then we get our second vec3. And this is going to be, so this one is, we're going to have, so the ray origin is like where the pixels are going to be shooting out from. And so that is kind of like we're using our screen as a lens into this 3D environment. And so the pixel's position is going to be used to determine the ray origin. So it's going to be like UV, and then we want it to be like influenced by the camera position. So if like the camera moves, the basically like this frustrum that this ray origin screen kind of makes, it moves with it. So the
UVs are flat, right? That's an XY position on the screen.
And then for the third dimension,
No, go ahead. I'll add my thing after.
Yes, and then the third dimension, since we don't have like it's basically like we're creating like this frustrum, like this little screen to like cast the pixels through. Like where is this going to be? Well, this screen is going to be like in front of the camera, and so it's just going to be like camposition.z +1.
Cool. Okay, so what I was going to say was the first time that me and Ilithya were trying to work this out, I got confused about, to me, I guess because to me the position of the camera is the ray origin. No?
It is
position
that,
of the
yeah.
camera?
Shoot it from
It
the
is,
camera.
yeah. Like I guess it's like it's hard to so the ray starts from the camera and then it
Yeah.
gets
Shoot.
pointed in the
But then it gets
ray
farther
through
and
the ray
farther away.
origin.
Right.
Yeah, you're right. But I
Okay.
think that this could be named differently. I guess it could be kind of like screen into 3D or like frustra.
Ooh.
I remember that we were renaming our variables and we call it
Yeah,
like
that's the thing. We
ray
got all tied up in a
start
knot of like wording
instead
because
of
I was like,
yeah,
wait, what?
instead of ray
But
origin,
that's-
I think we name it like beginning or something like this. I don't
Yeah.
remember, but I
But
remember we
anyways,
were
the
having a
ray is not
discussion.
the camera. The ray shoots from the camera. So it makes sense that they would be two different things. No, I get it. I just confused myself. It's fine.
Yeah. But you could also, because also another thing is that because we're all just like making this up, you could also like visualize it such that the camera is like here and the camera is kind of like attached to the ray origin.
Yeah.
And then like as you move the camera around, it also moves the ray origin around, kind of like
Well, like a real
Like if I were to,
camera,
like-
no? I always feel like if you would have like a real camera, like, and you have the lenses here and you're like looking like it's coming from, I like to see it like as if you had a real camera, like, and even when I'm trying to understand how 3ds works, like how you move around
Oh, like
the
if
3D
you look
world.
through the viewfinder and there's a little X in the middle and you're trying to fix it on your, that would be the ray origin. You remember the old school, maybe I'm dating myself right now, but
Which
do you remember like old school cameras where you would like look in the
Yes.
little viewfinder and there'd be like a little black cross in the center
Oh,
No,
okay,
I think
okay,
the ray-
yeah.
and you'd point it at a thing to, and you'd be like, that's where I'm looking at. You know, that's what I'm looking at. I guess that would be the ray origin. Anyways,
Yeah.
Is that a good
I think people
analogy?
understand.
I think if we're going with the real camera analogy, then it would be that the ray origin would be the camera position, but then we'd have to figure out what to call the ray origin
Yeah,
in this
yeah,
case.
yeah.
It would probably be like the ray spreader, maybe.
Oh yeah, but then no,
It's like
because
what
like
spreads
here,
the rays apart.
yeah. I mean, I guess the ray origin is different from the camera position, just in that it takes into account the UVs in the camera position.
Yeah.
design.
So it's like the camera position is here, and then it like spreads out from the camera position.
Yeah.
So it's like the rays start here, and then they spread out based on the
like
UV.
that. Yeah, I like that.
Okay.
Cool. Okay, all clear. Sorry for that tangent. Sean says, imagine the ray coming from the camera position and going through the pixel in the screen. Yeah, cool. So we're all on board.
Yes.
Awesome. Okay, so
Great.
so this is our camera, basically. These two, where's my cursor? Here. Let me just, the camera. Oh, crap.
And then should we name this something? We should call this like maybe like screen or spreader.
Spreader. Let's do it.
Spreader. It spreads it. Just rename this. Years of people who've done ray marching are like, no, it's called the ray
They're like ticking. Yeah, for sure. Okay, and so then now we need to build a second, like an exterior function now for the ray marcher.
Yes. But we also need to compute the direction.
Ah,
This is the
yeah.
last thing. Yeah. Because
To
we need the
follow
direction.
it, because we
and
need to follow it. Is that why we need the
Yeah.
direction, right?
Maybe this could be like. It's almost like the second ray origin, because now I'm like thinking, because when you put it in the trace function, you pass it in the ray origin in the direction,
Yeah.
and so it's like you use the, anyways, yeah. So maybe this should be called like,
Why then?
second ray origin or something, or like
Just leave it as ray origin, and maybe when we finish, it's gonna be easy to rename it. I figure.
okay,
Yeah.
I mean,
Yeah. No, because we could spend
Ray
hours
direction.
on wording. We've done it before.
Yeah, exactly. When we were alone,
2 hours
we
and
were
it came
like,
to bind. We're like, are you sure? Is this clear?
yeah.
So Tater made a really good point, and they say that
Yeah, I
I
just
thought
read
the
that,
the ray direction was what spread the rays. That is true, but you use the ray origin to create the direction. So the direction
Stems
function,
from the origin.
yeah, it stems from the origin. So yeah, so you can do like ray origin.
I feel like you should
Minus.
like continue, and then we can step back to kind of.
Yeah.
Oh, okay. Ray
Wait.
origin.
Ray origin. Okay, yeah. And then
Oh,
that's
that's
ray
color
direction.
stir. Yeah, I'm kind of doing
Yeah.
this backwards.
Okay.
I also like was up late last night irresponsibly.
No worries.
No, it was Friday. Come on.
Yes, I know this. I'll say this so that it's so we all yeah.
Yes,
Ray direction,
perfecto.
ray origin.
Yeah.
Cool.
And I think this is correct. I always mix this up. I should just commit this to memory. But I think it's like, okay, so basically we get our direction, and the direction is a vector, which is a direction that it's like an arrow that is 1 unit long and it goes in a direction. And so the 1 unit long is where we get the normalize.
Yes.
And then where we get the direction is that, so you take your ray origin. So it's like, if this is your screen, your ray origin is here.
Yeah.
And then if you subtract the camera position, like let's say my face is the camera position, if you subtract these two vectors, what's left is like the direction from here to here. You know what I mean?
The distance. It's kind of like the distance,
Okay.
right? So
Got it.
Yeah,
in
exactly.
between.
Wow.
The distance in between.
And then, so someone says you could also have the ray go from the pixel behind the ray origin through the ray origin and then out into the scene, like in the eye. It would work almost. Yes, it's exactly right. Yeah,
Totally.
you know, it's like you can it be like inverted, but I kind of like to have it be like
this
you
is
have
the
your
part.
camera origin.
This is the part that probably we meant. That's why I find confusing when you're reading and learning about raymarching. Like some people like define the first stuff differently depending on what they wanna.
Yeah,
and that's when
like
it's my head.
Yeah,
Yeah, exactly. And then I'm like, my head is exploding because I'm not sure like which one should I use. But then I'm I'm beginning to understand that I should just use the one that I'm just more comfortable. Like
but I mean, the eye
is.
and the camera are the same to me because you look through the camera with your eye. So it's like. But I think for me, I just had like I think it's fine. My body just like absorbed the information. The ray origin isn't the camera position at all. It's like the screen. The ray origin is the screen.
Oh, yes. That's always, I love that aha moment where you're like, oh, I get it.
Yeah.
Super.
Oh, okay.
And then now we're going to make our trace function. So instead of this being RGB, we will make this be trace. Trace. And then the trace is going to take it in ray origin, or
and the ray direction,
and then ray direction, and then it's complaining because we don't have trace. So let's go up here and then we're gonna have trace return a color. So vec for trace.
Trace would be basically what sometimes it's called the raymarch function, right? So just
exactly,
to, like, put it for people out there who maybe are watching this, and then in most tutorials they call it like raymarch.
And then we just pass those in here. Thank you for writing that. And in the trace function, this is where it gets super interesting. This is where we start to get all the circles bubbling out. The trace function, in short, what it's going to do is there's going to be an iterative for loop that will march your ray position along a distance as it projects.
This is max steps, right? Yeah.
Yes.
Okay.
So for however many steps you want, it could be a variable, it could be whatever it could be like. We usually make it like a power of 2. It could be like 32. It could be 512. We should probably do like 16.
Eliza, what are you opening?
Oh, I'm sorry.
Your crinkles are so loud there.
Oh, I muted myself for everybody.
Is it candy?
Yeah, it's like
so no one can hear but me. Okay, my bad.
Yeah.
My bad.
I always mute myself, but you two can hear me. So.
Okay, cool. Awesome.
We're getting the full experience.
It's pragma, right? I do hash pragma.
Oh, you can do define.
Define. Thank you.
Define and then space. You don't do a semicolon or anything. You just do define your number.
Max steps.
Oh yeah, steps.
How many do we want? 100?
You don't even have to put it. I'd say do 16. Honestly,
I don't.
You don't have to put a semicolon. Just do max steps 16.
16. Okay.
This is another question that I have, Char. Why sometimes like these steps are like a lot? Like more than
because people like to have, if they have like a lot of detail, like let's say they have like a fractal, they will want to have a lot of steps that kind of get that detail in the fractal. But like we're probably just going to do like circle, or not just
A sphere.
probably do like like a sphere or
Then
like
you don't need that
something.
much detail. Okay.
Yeah, you really just need like honestly like we could even see what happens with 8 and it'll like we'll see.
Okay.
But I think 16 is like a good number.
16 is good. I remember when we did the workshop where we had the sphere and the waves. I think I tried 8 and it wasn't. That's when me and Eliza actually met. It was during the raymarching one, I think.
Yeah, that's where we met, I think. So.
But yeah,
one day.
I think so.
One day I want to do fractals. One day I'm gonna psych myself up.
Get Soul.
It's on my list. Yeah. Cool. Okay. So we need our for loop. We have our max steps.
And I'm just gonna do something weird right now because this happens to me a lot where I start writing the for loop and it can compile the for loop without finishing it and it will compile into an infinite loop.
Like in shader place in particular or?
No, in every single, because it's like it'll always be compiling. And if you say like for empty, I think sometimes, or like for some iteration of the for loop, like if you do for empty, it'll like just turn into an infinite loop and it kind of messes you up. and so what I'm going to do is I'm just going to write some gibberish. I just did 𝗶 over here so that doesn't try to compile while we're finishing our for loop.
I wonder if that's what was the problem when we were doing our phyllotaxis with a for loop with Dan. Computers kept freezing. That must be it.
Oh my gosh.
It could be that we had the infinite loop, kind of.
Yeah. I mean, I love an infinite loop, but
yeah, same. It's very love a good spiral. Yeah. So okay, so I also don't want to like take over too much because I could just kind of be like, okay.
No, but you should. I mean, that's why we brought you here. So because you're really good at raymarching, so we figure
you are.
It's great that you come and share your knowledge because
But if you're tired of typing, we can also.
No, I love typing. I love doing it.
Okay, no, type away then. Type away. It's
okay, great. So the things that we're gonna need for this process to basically paint the pixels in our scene. We'll paint the pixels the color of the things that are in our scene. Rather, if there's something there, we paint them white. If there's not something there, they're going to be black. The things that we need are variables to store the distance. And so that's that distance that I was talking about, a point in space to the surface of an object. So like my face, like that's the distance that we need to store. We want to store the total distance as well, because we want to be able to create, when we return our color, we want to be able to say like, if it's close, it's white, if it's far, it fades to black. And so that kind of gives you like, it just gives you like an easy way to color it that kind of looks 3D. And then we want we want to keep track of where our position on the ray is. And so let's start with that one. So the vec3, did I just say vec3 position on ray, and that's starting at the ray origin. And I think that's one of the reasons why they call it origin.
Yeah. Okay.
And then we want our float dist equals 0, so it starts off at 0, and then float total dist equals also 0. Great. And then this is all we need to start our for loop. And so our for loop is going to be, thank you for making max steps, int I equals 0. I already did that.
You're missing an I.
I know. Yeah.
I got
this
you.
is my tired brain.
No worries.
Don't worry.
I is less than max steps. I plus. And then we want to say our distance equals a scene function that we haven't written yet. And the scene function takes in a position on ray. And the position on ray is then changed after we like get the distance, we want to update our position on our ray. So we say, because we need, so we like get our distance from like the thing in the scene, and if we wanted to like march along the ray, there's a bug in my room. So if you wanted to march along the ray, we need to we want to march forward only the amount that we know that we can before we
Yeah.
hit something.
Mhm.
Yeah.
Yeah.
So the position on the ray wants to march going in the direction that it was given.
Mhm.
So we want to go forward, so plus equals, so going in the distance that we need to go, the direction.
Do we need a
So in
step
that
size
direction.
then? We do, no?
A
We
step
need a what?
size.
What
A
do you
step
mean a step
size, no?
size?
Like a size of the step that it can fluctuate over the distance that
That's-
it needs.
Ah,
I think that's dist.
Oh yeah,
That's our
right.
step size.
No, my
And
bad.
then, no worries.
I'm like in parallel to like you explaining this, I'm like going over all of the different things that I read and like I'm like, oh wait, is that this? Is that that? I'm
Because
like,
you can do that.
too.
You can
Yeah.
like, instead of using SDFs, you can just march like a consistent amount
Yeah.
every time.
I think that I saw the guy from Art of Code do that and I was like, what? He had a max
That's true.
steps
He
and
does
a
do
max
that. Yeah.
or a step size and he put a dot so that it was a floating point number and I was like, I don't think I've seen that before. So, but the equivalent is basically dist and it's a float, so that makes sense. I retract what I said.
Well,
Okay, cool.
we do need it, and we have it.
Yes,
All
we do.
what is it? All
Everything's
that I
taken care of.
have. It's all that I need. I already have, and all that I need.
I love that.
Yeah.
Even getting started. I love that. Alethya's not on TikTok, so she hasn't heard it, but yeah. I'll send it to you later.
I don't know what you're talking about.
Yeah.
I love that jam.
Yeah.
Okay.
And then, so back to ray marching. So we marched our position along the distance, the trajectory. So the distance is a vector, remember? So we're marching along this vector. And this is an example of why the direction needs to be normalized, because if it wasn't normalized, we would be scaling the distance that we would march. And we want to preserve the distance that we're marching along this ray. But we just want to change the direction. And so that's why it's really important that we normalize it.
Cool. Okay.
Oh, Sean, I think Sean says, constant steps are good for marching clouds or transparent objects. That's a really good point.
Oh.
Yeah.
Ooh.
Okay.
That would be really
Probably
fun to do.
that's
write
why-
I did clouds once in Unity.
Yeah.
Nice.
And you've been doing
yeah.
this like refraction stuff, so probably that's why you were using that. So in the tutorial, like you were saying that you were watching also, probably that's why they need it.
Definitely.
So.
Definitely. I need to put that in my own language so I can do it on here with you guys at some point.
Yay. That would be really fun.
If I could explain refraction, I love the effect. So
Yes.
that'll be for a future stream.
Wonderful. Okay, so we have our position on array. The other thing we need to keep track of is our... Oh, thanks for starting.
Yeah, I'm just...
The other thing we need to... Total dist. I should have y'all... We should teach a class together. That would be really fun.
Oh my God.
Oh.
That'd be cool.
So then we just have our total dist, and then that is just keeping track of... We just keep adding our distance to the total distance because we want to keep track of that. And so now we have like in each loop, I'm just going to reiterate because I'm going to say things again and again so that it kind of like helps
Then it'll
people
sink in.
cement it.
Yeah, definitely.
So in a singular loop, what we've done so far is that we have an array in space, a point in space. We asked, hey, scene function, what is the closest thing to me? What is that distance? Just give me the distance. I don't need anything else. The scene says 3. It says whatever number. It says 2. And then the point in space says, okay, I know I can march 2 in the direction that I've been going without hitting anything. In fact, I could march any direction 2 and I won't hit anything. But because I'm going in this direction, I will march to, the direction that I need to go in. And I won't hit anything, and it's, and that's good enough. And then total distance, just keeping track of that. But what happens when it returns, like, you're at the surface of the object? So when you're at the surface of an object, like if you're touching the object, like let's say like your object is actually 2 in front of you instead of like 2 below you, that's when it would end. If it's 2 in front of you and you march 2, and then you're at the surface of the object, the next iteration it would end. If the object was below you, it was 2 units below you, it would march 2, and then it would return, maybe 2 again, and it would march 2 and stuff like that. I mean,
Okay.
so and so forth. So what we need to do to like basically when we hit something, the distance on the hit iteration is going to be very small. It's going to be like maybe it will be 0 because computers are discrete, but it will likely be just a very small number. So we can say if dist is less than
Yeah.
small number,
This is what it's
and
called the
return.
Oh,
epsilon,
this is
no?
your
So,
epsilon.
yeah.
Yeah. Cool.
Yeah, we can maybe define an epsilon up here, and then we
Yeah,
can use
normally
that.
we define it up there and then we.
Here, I'll do it. It'll be my
Yeah.
contribution. Epsilon. Epsilon in big. Epsilon. And it'll be 0.001. Okay.
Oh, I've been using, so in the chat, they're talking about NeRF, neural radiance
Oh.
fields.
Yeah, I
It
just saw
creates,
that.
it basically raymarching with machine learning to estimate the scene. That's really interesting.
Okay.
I've been using that at work because we've been like trying to
Really?
synthesize views. Yeah.
I see Alethya's curiosity is also piqued because she loves machine learning.
Yeah, at the moment. Really
I'm gonna have to
into it.
look at that. I have no idea what it is. I have
It's
no
pretty
clue.
cool. So basically, it's like given like a bunch of images, it can create like a 3D image based on that using like
Wow.
this machine learning
Ah.
technique. And
That's
so
so
then you
cool.
can like smoothly interpolate between two images, two views of like an image.
Can I ask a really ignorant question?
Cool.
How is this any different from like a GAN? That sounds, when you say it like that, it sounds similar to me. Just like in
I
my
think-
head, the way I'm visualizing it. I know it's not the same technique at all, but like visually, it feels the same.
Right. I think like GAN is about, okay, I guess like creating very new information. This is like a specific way to create like an image. Well, like if you were to like a GAN is kind of like general purpose where you can kind of like you have like your generative like model, then you can basically like traverse that space in there and like create new things. But I feel like with this, it's like a very specifically tailored to this one problem.
Got it. Okay.
If that makes
Cool.
sense.
Yeah.
But maybe Ilithya can elaborate since you've been doing machine learning.
You've been doing it a lot, no?
Yeah, but not like, I don't want to have an opinion on it because I'm not an expert. I'm still learning, so.
I don't think you need to be an expert to have an opinion on anything.
Yeah, that's true. But yeah, I don't know like deeply. So.
No, I mean, I played with GAN. I know there's like, well, I don't know, 75 dimensions or whatever in there that you can like flip between. But that's why when I hear you talk about it, it sounds like what I visualize when I animate my like GAN export, like the video from Runway or whatever.
Yeah.
Right? But yeah.
Char is
Sorry for the
thinking.
tangent.
Char is thinking.
Oh no, it's just
GAN has two networks
I'm trying to,
competing, but it sounds like NeRF is just one. Oh, single versus multiple networks. Got you. Yes. So the two networks competing in GAN is the merging between the worlds that I have visualized in my head. Whereas you're saying that you have one network, and within that single network, you're going between two shapes?
two like views. You can
Views,
interpolate
sorry.
between.
Okay.
Yeah, and then that creates your images.
Cool.
I'm trying to think of how it's like raymarching, and I'll have to look it up.
Yeah, I'm so curious. I need to Google it too and to like see it so I can see if it has anything to do with what I'm picturing in my head right now. Cool.
Oh,
click on that link and save it.
So, okay, moving on. So what we want to do is like when we hit, so I'm on line 34 right now. What we want to do when we hit the surface of an object, we want to return something. We can return like 1 for now, but we can also just say like 1 minus total dist divided by max dist or dist, and then we can define max dist up here.
Oh, that's the one that it's a big number sometimes.
Yes, exactly.
Maybe it was not the max steps, the one that I meant. Yeah, it's the distance. would the distance as well be the same as the steps? Like if you're doing something, like you said, more detailed, that then you want to increase the distance too?
Exactly.
Okay, so then
Yeah.
you
So
increase
like,
both of them.
yeah, maybe we should make this a smaller number for the computer. We don't want like, so it can be like, we can say like 25, or maybe
Okay.
I'll make it another power of 2. 32. Maybe we'll just do 16. Sorry, being really indecisive. Great. And so the next thing that we want to do
I have a
is,
question,
oh yeah,
by the way.
yes.
You have this direction here on line 32. Where is that defined? Because
Oh, I'm
I was
sorry.
like,
I messed this up. It should be ray_dir.
oh,
I just
okay.
kind of, yeah, good
Because I
call.
got lost like there before, but I didn't want to interrupt.
Cute. No, thank you. I always do
Okay.
that where like I kind of have like
No, that's
canonical
fine.
naming, and then I just like go with that. And scene. Oh, scene is going to return a floating point number because it needs to just
Oh,
return
okay.
like a distance. Yeah. And then this needs to return a vec4. I'm kind of like chaotic
Ah, true.
coder where I just like code it out and then I like go back and like fix all the messed up parts.
I think
I think,
it
yeah,
happens
we
to
all
me.
are.
Yeah. I'm too tired today, by the way, so maybe that's
I think
why I'm
everybody is.
slow
I
and
just
not
like-
speaking too much.
I'm just adding my points because it got mad at me because it thinks that if there's
Needs a
no
dot.
Yeah.
dot, yeah, period. And
Floating
then,
number.
But so scene is a float, you said, right?
yes, indeed.
Okay. So we have our
Great.
float scene. Do we still need the 𝗀 now that we have our for loop, or are we good?
The
Need
what?
the the 𝗀. I guess we
I
don't
was
need
like,
the
which
𝗀. Well, I think okay. There's one more optimization that I want to do before we remove the 𝗀.
Okay.
So
the
there's
return
one
of
more
the
thing. So
background, I think. No, so you're gonna return something else.
Okay, so
yes,
if total distance.
is greater than, because we made max distance, right?
Right.
And then is it max
It's
underscore
total
dist?
dist. Wait, it's
Oh,
total
total.
dist. Yeah.
Oh, sorry. And then
No.
max dist. Okay, then max dist. Then we just return
Oh, right.
the background color.
Yeah. Yeah, like black or whatever. I don't know.
Yeah. 0. Great. And then it's still mad at me here. Oh, right. Vec4. Why is
Oh,
this mad at me? So
because you needed. That's not a vec 4, isn't it? We need like another. That's a vec 3.
1 minus.
oh well, we can this should be shorthand. Like I can do the same way that we just did here. Like this is line 38 is
It should
compiling.
compensate.
Yeah. So line 38 is fine, but line 35 it's mad at me trying to
that's
figure
true.
out.
Says that there's a syntax.
Oh, it's probably because there's a okay, this is a really
Ah,
great
the
one.
semicolon undefined.
Yeah.
Semicolon.
You don't
Yes,
need
okay.
that.
So basically, I think this is a great
Oh, I
like
forgot. Yeah.
like look at this for a second. So basically what's happening here is that the define on line 17
Oh, my
is
bad.
defining
Is that me?
this. No, but it's like this is something that like
Yeah.
that I do all the time, and I think that it's kind of, and it's really interesting too because basically what this define does is that in the compiler stage,
Yeah.
it basically takes every instance of like max dist and like replaces it with whatever the hell is in here verbatim.
Oh, so now we have it. Okay.
Yeah.
funny.
So
Got
right?
it. I was so confused by that error too. I was like, where is the semicolon supposed to be?
Right.
Okay. Awesome. I didn't know that.
Right?
Great.
I know. It's great because you could use it for a lot of optimization stuff, and like it's just a great tool to have in your tool belt.
Yeah, Flopin told us that when she came, that she uses a lot of defines when she's doing her
Flopin,
shaders.
yeah,
Because it's
she
just like
defines
more
even
performant.
shapes.
Yeah,
Yeah.
exactly.
Oh.
Like she was telling us that a lot of like little functions, for example, like to create a circle or whatever, she just put it in the define already because it's
I
just
remember
more
seeing her
performant.
do that on one of her streams, and I was like, that's a lot of defines. But
Yeah, exactly. But
yeah,
it
I
seems
guess
that
in
it's
the
more.
end it's lighter. I know
I love
nothing
it.
about optimizing, so I'm always curious.
We do
to get
now.
better. yeah. Actually, there was I don't know if this is an optimization thing. No, it's probably not. But there is a question in the chat about, is there like an actual reason why people do powers of 2? Like
It is
you were doing
optimization.
16.
Oh, yeah,
Is it? Oh,
Yeah.
cool.
Yeah,
Why?
because like
Shader says it's just
basically
the right thing to. It feels like the right thing to do.
a lot of times, like when you're working with, I mean, like registers basically are powers of twos. Like, I mean, like buffers are in powers of twos, and memory space are in powers of two. So a lot of times it's like the way the computer will like move around space is that it's like move around memory in space is it allocates things in blocks of twos. And so, I mean, I don't know. I mean, I think that it translates to like the variables that we use because it's like we do this 16 times, right? And then it'll, you know, it'll have like a something power of 16, you know, 16. So
Yeah,
That's very
Cool.
good to know because I was
yeah,
wondering
caching
about
and,
that the
and
other
stuff like
time
that.
too. That a lot of like shader stuff has like I think fractals as well has an equation with
yeah.
like the square of. So and I always wonder why 2 times? Why not 3 times? Why not 4 times? So
Oh, our words aren't on the Twitch stream. Is that okay?
Our words. Oh shoot,
oh,
good call. Oh, we don't have the captions turned on.
I totally forgot when it was resetted.
That's
If I turn
okay.
them on over here, does it turn on for everybody?
Now it
just
should
turned
be
them on.
there. No, but
Okay. Oh no, that's like one of our favorite
yeah,
features.
I know.
Sorry. GPU buffer and chunk size are power of 2. So it's more likely you'll fit nicely. If you start breaking that, padding content can have server consequences. Thank you,
Oh, okay.
SciCode. I didn't know.
Me neither.
Yeah,
What kind of
curious to know
consequences?
what.
So basically, the consequences are that it wastes space.
Got it. Okay.
It wastes space. and
Now
it, like,
Sean
and
is
then-
asking what kind of consequences.
Like it'll slow it down.
Yeah.
Yeah,
Yeah, I
that
guess
would
if there's
be
not enough
interesting
space, it
to
starts
know,
to chug.
like,
That makes
not
sense.
severe,
Server.
not server,
Severe.
severe.
Oh, severe. My bad. Severe consequences. Sorry, guys. That's
can
me.
expect
I need to
No,
have
no, no.
glasses on.
No. He did right. I mean.
Oh, he wrote
say-
server?
could-
Okay.
Yeah, he
I
wrote
thought
server.
it was me being blind. Okay.
Or, oh no, oh wait, no, actually, just kidding. Server. Just
I think
kidding,
we
I'm
should
also
just all
blind.
read.
Anyways, yeah, we should all just.
But
anyways.
basically, severe consequences that include slowing down, which makes
Yeah.
sense.
Yeah.
I mean, the less space you have, the more you chug.
Yes, you can expect computation slowdowns.
Huh. Interesting
Anyway, let's
insight.
get back to our Raymarcher.
Yeah. Okay. So we have little errors, but those are normal errors. 'Cause we
Yes.
haven't
Yeah,
integrated
because
the
we
function
have
yet.
an empty function, so
Yeah.
we need to
Yeah,
return
so
something
let's
like.
define our empty function. So we can just. Oh yes, do it.
I know a
Go,
float
Alethea,
actually.
go.
Can you do Can you
But why it doesn't?
rewrite
Yeah.
the clear function?
What? No, I was actually gonna ask because we still have like below the where we have this query. I wanted to ask you like before we jump into the scene on the trace function. Normally, like outside the loop, we return as well like the background again. Do you do that?
What was that? Oh, you turn the background?
Yeah, again, like outside the for loop.
Oh yeah, totally. Yeah, we should do that. Absolutely.
And I wanted to ask you why. Why would one need to return again the background outside the?
Because if the case is that it doesn't march the max distance, but then it also runs out of steps, it needs to have a color. And so then basically it's kind of like if you have like a floor and oh wait, let me see. Yeah, if you have a floor and you run out of like steps before you hit the max distance or before you hit anything, then you need to return like the color of what you're looking at, which is nothing.
Ah, okay.
Yeah, so that happens if you're like marching along and then there's like a thing that you don't hit, but you get really close to hitting it and you like
Then
use
you
up all of your max steps.
Yeah, and can you then say again like the other one that we have over here inside the for loop, like if the total distance is higher than the max distance, and then we return?
Yes.
When
So
does
that's
that
like-
one return?
So that one returns, so like let's say you have a sphere that's like very far away. Like your sphere is like, let's say it's in the left-hand corner. Like your sphere is like over here, right? You have a sphere here. The ray that's in the right-hand corner will march really far because it's far away from the only thing in the scene. It'll march really far. It'll march like, 5, and then it'll march 5 again. And then by that time, it's beyond the max distance. And so then you can just know that there's nothing out there, or rather you don't define anything out there. So you can just return nothing.
Okay.
And that's an optimization. We actually could take this out and then we wouldn't need it.
Okay.
And then it would actually run fine, but then it would just go through all the max iterations every single time, even though there's nothing there.
Okay, that's why it's better kind of to put something. So.
Yeah. Any other questions?
No.
Great.
But wait, we can now delete the line.
Yeah, we can delete the 𝗲. Yeah.
No,
it's not going to show anything because our scene function doesn't return 0, but it'll compile.
At least something white, because it's here, the floating number. So.
Oh, we have a syntax error. So this is this if statement. This is this for loop. What's wrong? So 45, it's mad at us.
45, really?
I don't
get
it.
an error.
Me
Oh,
neither.
you're not getting an error?
No. I don't get it.
Oh, okay, you're right. Sorry, that was my
Because I was changing here in the scene the floating number.
Yeah. So we could use some. Yes. Perfect. So we can write.
You're
I was going to write a little spheres function.
Yes, do it.
I only know I know a mix between Inigo and Bokeh shaders. I mean, I think it's probably the same one, but I know that there's like a way to do it in a single line. Really?
Yeah, he's in New York right now.
Oh, are you going to hang out with him?
We've been like trying to plan it, but we keep missing each other.
Oh no, you guys have to meet. Have you met before?
Yeah.
We've met virtually.
Oh no, you have to meet in person. He's so lovely.
Yay.
He is really, really lovely.
Yeah, the only thing is that he's in Manhattan. I'm in Brooklyn.
He's staying in Manhattan?
Yeah, because he has work there.
Oh, I see. Oh, right. He's at Runway.
Oh, maybe, am I blowing up his spot? Oh my gosh, no one.
No.
I'm not blowing up his
I know that there's a way. Oh, sorry, go ahead.
I'm just like, he's not here.
No, I'm sure it's fine. I know that there's a way to write a sphere in like a single line within a function, but I only know how to do it this way. I'm sure that there's like a more succinct way, but
this is perfect.
Okay.
Beautiful. And so let's do sphere. And then we need our position.
Yeah.
And then let's just do
just like the radius.
0.25.
Did we not optimize our?
What do you mean?
Oh no, we're doing regular resolution. We didn't do our usual thing that we do.
Wait, does that look good to you?
It looks a little squished.
Yeah, for me too, like an ellipsis.
Yeah.
Yeah, so we can use
like an egg. That's fine. I don't mind. We can have an egg. We can. We can also mess with
resolution. Yeah, we could do that. We could do that real easy.
It's
so
minus...
norm chord.
Yeah.
Chord.x equals or times equals.
Yeah.
Resolution.x divided by resolution.y.
Yeah.
Cool. Now we have a circle.
Beautiful. Unfortunately, our screens are not square, and we have to normalize for everything.
Yeah.
Great. Yeah, you need to account aspect ratio. That's all. Indeed.
Yeah.
Okay. Cool. So now we have our raymarching scene, and if we wanted to see, we can add a floor. This sphere is like the second to simplest raymarch function. The simplest is floor, which I'm not even going to write a function for. I'm just going to say, I'm not going to call it floor because that's a function. I'm going to call it ground.
Ground, yeah. Wait, where are you guys? See, you're in scene, and then Ilithya is typing something else. No,
I was trying to get a color return.
In the background?
Yes, that is not black.
Yes.
But
yes.
Oh,
Root
my computer
y plus
again, it's
4.
a little bit froze. So, okay.
Oh,
Oh,
it
no.
froze again?
No, it's a little bit slow, but not frozen. So
Okay.
just
Okay.
takes a second.
Let's reduce this then. Let's make this 8,
Okay.
8.
Oh, there we go. I see
cool.
a background.
Yeah, me too.
Why is there a stroke around the sphere?
I love it.
I think
Here for it.
What is the stroke coming from? Oh, is that what the extra color is? My bad. Okay.
What extra color?
Is your computer a little faster now?
Yeah, now I can scroll again.
Great.
Mm-hmm.
Wonderful.
Yeah, this is so weird that it makes it slowy.
Ooh.
This reminds me of your workshop.
Yeah.
Like I'm having flashbacks. This is
Me
so
too.
great. That we have a ground and a sphere and yeah.
Yeah, I'm trying to figure out why it's not doesn't look very good for some reason. Like our Macs, like it looks very white, black and white, and not any sort of like
What do you
Is
mean?
that
Like
'cause of the amount
2D?
of steps and
What does it mean?
yeah.
Let's try
Maybe
to.
because-
I think it's the steps and the distance. Maybe we can increase that. That's why it looks 2D instead of
But then your
3D.
computer will freeze.
True. Maybe we can do it for a second and then back.
Yeah, we could.
Yeah, let's just do that.
Just for a
No,
second.
I don't want to do that because.
No?
Oh wait, that looks good. What's happening
Okay.
here?
Let's just test it for a sec.
Yeah.
Oh, that is indeed it. Yeah.
Yeah.
I think it's that.
Shoot.
So, but this is interesting because I think I never like try it like in both in the steps and the distance, and then you have like this kind of 2D ray march, so you don't even have the 3D
Right.
effect at all. So it's like painting in 2D.
Yeah. It's like a cartoon shader.
Oh, yeah.
Maybe we can make it such that the max steps are big and the max dist is small.
Try that,
So if we
try
do this
that.
8,
And then I see my
this
computer.
We need to make
8.
it 4.
Okay, this looks a lot better.
Yeah.
I mean, like it's like the circle's like really close up, but
Yeah.
32 and 4. Okay, that works.
Yeah, my computer is still
Needs
fine.
some light. Yeah.
So I think we're good.
Ooh.
great. Okay, super.
It looks like a mountain and a sun or a moon.
Right?
A moon over the.
And we could move the sphere around to make it look like it's the sun. And I saw the eclipse the other day.
Did you?
Yeah.
I went.
The
Wow.
longest one in 1,000 years, you
Cool.
guys. The
Yeah, it's
longest
crazy.
eclipse in
So
1,000 years.
lucky.
So jealous.
Yeah.
I saw that it was
Yeah.
only visible from North America. I was super bummed. All the eclipses are always
Nice.
only visible from
Really?
the US and Canada. It's really
Yeah.
frustrating. I'm never there at the right time. The last one, the crazy one, like from, gosh, when was it? A couple years ago. It was so beautiful, and everyone was watching it live on the internet because it was a solar eclipse. It was also only visible from your part of the world.
Oh, you need to apply the max dist case because you're running into that one first. Oh, so we need to change the.
Mean?
No, I think
Or
that
which?
this is correct. That we have this one first and then this one. Is that what you're talking about?
Someone said it looks like the Tycho album art.
What do you mean, like
It's true.
Max?
Yeah.
Need some light. Yeah, I guess so. So we can. Okay, great. She did it. Great. So we can do a few things now. We can write our lookAt function. We can kind of like iterate on the scene and like add more circles or like, add different shapes and SDFs and talk more about SDFs.
I think we should check out your lookout function. That's
Yeah.
what you mean, no?
Yeah.
So I feel
Oh,
like we should
okay.
thoroughly
I agree.
look on that.
Yeah.
I agree because
I
I'm
was-
excited about it.
Yeah, right. Because it is very like it's very technical. Not tech. Yeah, I guess it's like it's not going to look good for a little bit. It's just going to be us writing for a little bit, but I
That's
think
fine.
it's really fun to talk about.
Yeah.
Mind if I just like pop in a cosine palette function
No, definitely.
No.
Always. We love a cosine
and then
palette.
Feel
and then we
free.
can use that. I always love.
Ooh, Sean votes for lookAt as well. Yeah.
Yay!
Yeah.
Maybe I
want to
should,
learn
should I
that.
just do that? Maybe I'll just do that
What?
instead
The
of.
lookout or the color palette? Yeah.
And yeah, just to go straight to the lookAt.
Yeah.
We
Let's
can add
look at
color
that,
at the end.
and then we can bring the color palette after you explain the lookAt.
Okay. Okay, so the lookAt function is really fun. And what it is that you take in your UV, like your position on the screen. You take in your camera origin, and then you take in a third variable that is the camera target. So right now our camera target is just like right in front of us. And we want to be able to like look, if we want to be able to like look around and like kind of swivel and pivot, we need to define the 3 axes at which the camera is like kind of moving at, so that we could like preserve this like rectangle, because we need this like rectangle of like rays to be always intact as we like move around.
Or maybe in the screen.
Oh, so the lookAt is gonna be like controls, kind of
Yes,
right?
exactly.
So I'm thinking about 3S, like when you have the orbit controls, for example, and you add them on the scene, and then you can literally like. Now
it's
clicking. Now it's
clicking. When you have it, the rectangle, is that you're moving the pic? Okay.
Yeah. I'm moving the screen and the like the ray origin and the camera origin with it. So like if my face is like the camera origin, this is like moving around like that. And you can even do like we can't like swivel, but you could always like pretend to swivel with like just a rotate function or like whatever.
This is so great.
It's exactly like orbit controls, but with raymarching. I'm sure that like,
this
orbit
is amazing.
uses this math. Yeah.
I imagine, because I've already like got into inside, because I was very curious the other day and I needed something that it wasn't working, so I had to go inside the orbit controls and create my own like public function, so for something that I needed. And I look at that math and everything, and I was like, wow, how they like managed to create this. So now when you're talking about this lookAt, now I'm very curious to see how you're gonna do it here, like with pure GLSL. Instead of like,
they probably use a matrix, which we're not going to use a matrix because I feel like
that would be a lot.
Yeah, it's just kind of, it's not going to be a lot of code, but it'll be kind of like opaque.
Yes.
And so we're not going to do matrix. We're just going to return a direction vector.
Okay,
so
cool.
Direction vector is going to be, we're just going to put it above main. So I'm on line 54. We're going to do vec3 lookAt, and then what it takes in is this vec2 UV.
Where are you, by the way? Because hold on.
Line 54.
Oh, okay. I have to scroll down because otherwise you weren't on the screen.
They weren't seeing it.
All I'm doing is just defining this function.
Oh yeah, right.
Cam target. So we have our lookAt function here, and okay, so we have basically, if we want to like preserve our like rectangle screen, we need to define the 3 axes to kind of traject like the pixels that are going left along the x-axis when it's rotated, like the x-axis of the camera swivel. Great. Oh wow! So we actually have some work.
That's funny.
He's helping maintain.
Wait, does orbit controls use like? Oh, actually, maybe we'll ask you after it's done, like how different.
Yeah. Let's compare.
Wow.
Okay.
Yeah.
That's so
that's so
exciting. Oh my
funny.
gosh.
Yeah.
it's
What's your
so nice to
name,
have you in the chat
𝗙𝗀?
with us.
Yeah,
𝗙𝗀.
exactly. So
if you want to reveal your real name, we're curious, but no pressure.
I was just curious because I'm often on the discourse of 3S, like especially when I had that issue with something that I wanted to do and I had to create like a public function because it was not possible otherwise. So funny coincidence. Yeah, anyway, let's continue.
Okay, so to maintain, so these are all the elements, right? We need origin, which is the ray origin.
Yes. Or this
target.
UV. It doesn't necessarily need to be an origin because it doesn't need the 3rd dimension.
Got it.
Needs to be like understanding that it just needs to be a 2D.
Okay. But then the
like
vec3 origin is the ray origin?
What do you mean?
That's the camera origin, sorry.
Oh, my bad. Sorry. Okay.
No worries. I should have wrote camera origin.
Cam target, which is the thing that we're looking at.
Okay.
That we're trying to
My
follow.
name is Guillermo, but I go by Sidecode online. If you're English, don't try to pronounce that. Guillermo. I am English and French. I don't know if I butchered that. I apologize if I did.
Yeah, maybe I've seen you. I'm trying to remember, but
Well,
Okay,
thanks for being here, Code.
we're excited that you're with us.
yeah, but
Yes.
thanks for coming here.
So if we want to define our three axes,
Yes.
you can get the z-axis of this new swivel using the same method that we used to get the first direction, which is vec3. So we need to get our z-axis. So that's the axis coming out you. We are y up. We are y up in this household. No z up. Get out of here.
Okay.
Yeah. So vec3, the axis is the same thing we did before. Normalize of our camera target, so what we're looking at, whatever it's this like point we're looking at, and then minus the camera origin, so then you get that direction.
To get the distance again. Okay.
Yes, exactly. Or the how we got our direction before. Minus camera origin. Great. And so now we have our z-axis. And next, so now we have like our z-axis, we are always gonna like, if we wanted to get the y-axis, like the y-axis that's going along here, so we have our forward axis, and we want to get this y-axis. Our stream kind of is okay. Good, it's okay. We want to get our y-axis here. We have our forward axis. We need the canonical way to get like another axis derived from like two axes is from using the cross product, because that's what a cross product basically does. Is that given two axes, it gives like so if you have like two intersecting axes, it gives the perpendicular axes to those two intersecting axes. So we have our up. Yeah, so we have our z-axis going here, and if we wanted to get our x-axis, we can use like the n up axis that doesn't necessarily correspond to like the swivel's up axis, but because it doesn't matter if the up axis is like pointed directly up, or if the up axis is like any other, it doesn't matter, that the x-axis is going to be the same. So we can just use like a default up axis, right, to get this x-axis. Does this make sense?
Sort of.
Yeah, I'm half.
So basically
there.
like the black
Wouldn't
magic
it
function
up
that
axis?
I have one question though, like about the cross product, because this is actually like that GLSL function that I've been trying to play with. I think it's called cross. And so you were saying, so you have the two vector trees, because it's normally like a vector tree, like two of them crosses, and you mentioned that then it returns something parallel to that, to where they cross. Perpendicular.
Yes.
Sorry.
Yeah, so it creates like the
that's why it's the cross.
it's the two axes creates like a plane. So it's like, so we have our z axis and our up axis, right? Like the two things, and
then
the
you need the other one
between these two.
Okay, now I
is
get
like
it.
If that makes like a plane, and this plane is going like this, I'm doing my z-axis derived dance move. It is this axis.
Okay.
Hey, can I ask a question now? I have a potentially ridiculous question, but an up axis, wouldn't that just be a y-axis?
The what?
Exactly. So it is. So let me write it out, and then it'll probably make sense. And that's not a ridiculous question at all.
Okay, cool. Because I'm actually I work in Lens Studio sometimes, and they don't do X, Y, Z. They do just up, front, back. It's very confusing. I'm like, isn't this just a Y? I don't know. Okay, so up.
So this is our default up axis.
Okay.
It's not the up axis of the swivel.
Got it.
Okay.
Because the swivel up axis can be like, as I'm going like this, like if this pointer finger is your up axis, it can be any angle. But any angle that this is, as you know, we just need to get this will be the same. So we're just using the default like up axis like that. Okay. And then we're gonna use that to get the x axis.
Okay.
So this is normalized. And everything is normalized because we're just getting axes.
I will ask when you finish, probably. Now I have two questions.
Yes, we did it. Yes.
The result of a cross product is perfect in the vector y plus x z plus equals x plus. Allow your camera to scale around. If you allow your camera to rotate, then you... I feel like SciCode probably understands quaternions really well.
Oh, of course. If he has worked with
Just reading his
3Ds,
comments.
if he has worked with
Like,
3Ds
so-
and build the controls, I think he does.
I'm kind of, yeah, okay.
Is that all? No, you're gonna continue to write the other axis, or?
Yes, I was wondering what your question was. I was pausing for you.
Oh no, I'm gonna wait because maybe it's gonna be answered
Okay.
by the time you finish. So I prefer to
Got
wait
it.
and then I will ask.
Wait a second.
Yes,
So you
and-
can fix a specific axis to a random up or forward or whatever axis. These are separate things.
So we are right now deriving the axis of the swivel camera.
Yeah.
Those can be anywhere, but there is still like the up axis. It's still like just up,
Up, right.
which is like
Y.
0, 0, 1.
Okay.
It's a vector that's going up.
But it's like
Yeah.
abstract, not... Okay, I get it, I think.
All of this is abstract.
Okay.
This is the worst part, yeah.
Yeah.
And so, okay, so, but basically like, I'm going to keep doing this because I feel like this really like illustrates like why we can derive the x axis from just this like generic up axis that's not really derived or anything. It's just like up, and the z axis, which we got from our from subtracting the 2 points in space and normalizing it. So like, yeah, so like that's why, so we're getting this point of our swivel. So this is in a swivel, and we have our z, and then the up, like if up is like here, if up is here, if it's 1 0 1 0, or if it's like any kind of wonky axis besides that, this is the same, and so then the x-axis is the same. Yeah, because see, when I do this, like this stays the same place.
Yeah.
Yeah,
Right,
so that's
right.
the reason why we.
Wow, okay. Yes, I've been having a problem all week trying to get something to rotate the right way, and I think I just understood why. Okay. Thank you, Char. You're saving my life. Wow. Cool.
Yay! And then the final axis that we need is our y-axis. So that's the axis that is going up.
Isn't
and now
it
that
that
we have
one?
our two.
Yeah.
What?
Isn't it the up axis, the y-axis then?
No, because so it's the same. It's the same if the camera is facing forward. But if our camera looks up, this up axis is no longer 0, 1,
you're
0.
right. It stays there.
So
it's a different number.
You wanted to move with the other ones along.
Exactly.
Right.
Yes.
Yeah.
Right.
livecode it explains it nicely too. He says, think of the real world. The camera doesn't need to always be oriented up, so you don't need to always have y up. We choose that to make everything simpler. Yeah?
Yeah.
Okay. I feel like everyone's on board.
Yeah, like I feel like we could use a different up axis that's like, but I wouldn't really know like what to do.
Yeah.
But like this one works, and we know that it is an up axis.
We can count on this one. Yeah. Okay.
I
Great.
think. Okay.
Let's see how it goes.
I know. Just in that explaining, I was like, does it? Anyways, there's always room to learn for me. So our final axis. So we have our x-axis and we have our z-axis, and we could just get the final axis by just doing the cross product of those two because we have them.
Yeah, that's what I imagine. And you have to normalize it as well. That was the next question then. Why you said, and then I'm gonna normalize it because it's an axis. What does that exactly mean? That you have to normalize an axis. Why?
So that it's not. Yeah.
So that, yeah.
Go ahead, Char.
No, Eliza, you can go. I
mean, normalizing, you're just making the number so it's like a direction, no?
Exactly.
Not like a length.
Okay.
Because then you can do stuff like multiply it by this, and it's not a scalar. It's only a direction. Because you don't want to scale things. You just want it to be
pointing in places.
Yeah, like the essence of the direction.
Yeah.
You can think about it like that.
I have to write that down here somewhere. You said because it's a direction and not a...
You want to use it as a direction, not something that will
not a length,
scale over a distance.
It's just sometimes I have to really digest this.
No, totally.
For later.
This is what we're here for.
Yeah.
Yes.
Took me
Okay.
a while to figure out normalize as well, like a long time ago.
Right.
To like
Exactly.
understand when and where you use it.
Especially because it's like it's used in different contexts. Like there's normalizing, which is like, making it into a vector. And then there's like normalize the UV coordinates, which is like putting it at like the 0, 0 point.
Yeah.
Maybe they're,
Yeah.
it's called basis. We just use these direction to match the world coordinate system. It's called a basis. Oh, so it was like this.
What is called basis?
What is called basis?
What do you mean it's called basis?
We
We
don't-
don't want it to have different sizes, so the world is not warm.
Oh, he's talking about normalizing it.
Oh, okay. Mm-hmm.
Right.
Right,
And
yeah, exactly.
We
So
could,
this is what-
unnormalize it and see what happens, which is the best part about writing this. We can just
Okay.
see what happens if we don't do it.
True.
Yeah.
I actually don't know. I mean, like,
Well, probably
anything.
now when I read what he said, like it's gonna be warp, so it means that it's gonna be distorted or.
yeah, but I want to know how. Is it going to
Yeah.
be warped in like a cool way or like a?
Could be.
or like
It could be a fun bug. We could test it
fun.
out when it was
Yeah.
working. We could test it out.
So the last thing we need to do. This is the trickiest part, and this is the part that you can do with a matrix, or you can do it by kind of like hand writing it out, which is like what I'm going to do.
Well, we're gonna do that. Yeah. No matrices.
Yeah, we're going to
Yes.
handwrite it. No matrices. Yeah. So basically what we're going to do is that so we have our 3 axes and we want to return like the direction. So this is returning a direction from the like camera origin And so,
do we need to return like a vector tree with the 3 axes now, or?
so right now it's basically just like 3 vectors that are like this or like this. And you want to, since we are assigning the direction vector to this, it needs to be in the direction for each of the individual pixels. Because right now this would be the same for every single pixel because we don't even use UV here. We haven't used UV yet.
Yeah.
And to like customize it to every single one of these pixels, we just basically need to apply the UV x to the x-axis. So you multiply those. And then you add UV y to the y-axis, and you add z-axis to the FOV.
So that you can really
you
follow
can
them.
direct- Yes.
Yeah, the
yes.
pixels on the screen.
We're reprojecting them in this new swivel that we made, basically.
This
Because
is
right now
just
they're like
blowing
this.
my
We want to project
mind.
them with our new swivel.
I'm
wherever
starting
that
to
is.
understand the orbit controls in 3 years. I feel.
Yay!
Yes.
Yay!
Okay,
That's awesome.
cool. I also feel like I
Okay,
want to
so-
save the chat with what was your name?
Is there a way to
Psycode?
save it?
Yeah, because everything that you're saying is so like.
Right.
I hope
I
it's
think
safe.
there's a way to download it as a
Yeah,
text file.
because
at
it
the
would
end.
be just.
I'm just going to do copy paste.
Yeah, yeah.
Definitely.
Because I want to read it in calmness. Because right now,
HTML.
like, I cannot follow the chat and do all of that.
Yeah, I wonder if, it'll be replayed in the replay on Twitch, which is
Yeah,
nice.
it's true.
Ah,
You
okay.
do get access to the chat again
Yes,
after. Yeah.
yes. Then good news. Okay.
Because I also feel like all of the things that Psycode is saying is very contextual.
Yeah,
what
but
we're
it's very like exactly. But it's very like good too. So that's why I wanted to keep a lot of
yeah.
those notes. So please, Psycode, continue. Like if you have more insights.
We take all
Yeah.
your thoughts.
Yeah, exactly.
I love that Psycode is just here, who
Chilling
helped
with
with
us.
camera
Yeah,
origin,
thank
and
you.
we're writing a lookat function.
Yeah.
Serendipity.
cool. Yeah,
chill.
yeah.
I think
Because
he's
I don't
gonna
think
stick
you've
around.
been here before, Psycode. I don't remember this like.
I don't
person,
remember
right?
seeing your screen name
Yeah,
before. Yeah.
me neither. So this is just luck. Cool. Okay, let's
Yay.
continue.
Awesome. Okay. So
So,
we've got 2
so-
axes.
yeah, so what we're going to do, so our vector 3 of a direction is going to be normalized UV dot x times x-axis,
Right.
and then we just want to add UV dot. All right, this is inside the normalized function.
Oh no.
What? No, I was really chilling and just popped into the stream because I love raymarching. Wow,
Yay.
nice. I wonder how you
cool.
heard about it.
Yeah, how you heard
but-
about it, Psycode?
Good. I'm having fun. Please do continue. Well,
Yeah,
we're
my
glad. We're
screen
glad.
my screen froze.
Oh no.
Oh, no.
I hope that this will like because I cannot see you typing anymore, Char.
Oh no, it's
Oh
true. Me
no.
neither. Shoot. Can you
Here.
guys still hear us? I feel
Can
like it
you
should be known that if Twitter is true, he's being this helpful while supporting an incredibly majestic mustache.
can you maybe reduce the max steps again or these numbers
Yeah.
and
Yeah, I
see
got
if that
it.
will
I'll do
fix it?
8.
Okay.
Just for the moment because I'm stuck.
So
I
you
mean,
haven't fully crashed because I can still see you.
yeah. And no, the good news is now that we're like having now
Oh,
yeah, now
he
I
found us
crashed.
like actually through
Now I
Twitch.
crashed.
That's
Now
so
I
fun.
crashed. Now I crashed.
I'm glad that we kept our tag as science and tech and not
I
something else.
crashed by the way, guys. So
Oh no.
Oh no.
everything is black. Not the sound, by the way. They can still hear us
Okay.
because I realized that this was great that we're like taking the sound not from the browser this time, so they can still listen to us. The only thing is that they cannot see us at all,
Oh, okay.
but we're there.
Well, everyone's talking about Psychode's mustache anyway, so it's fine.
I have a new idea. I'm gonna put Shader Place into another browser like Firefox or something instead of
I
Chrome.
think we did this last time. I
Totally forgot because
And
I
it was
have
helpful.
the Meet in Chrome, so I can keep
Yeah.
us there. And then I'm gonna
Okay.
put Shader Place here, and hopefully, if it crashes, at least it
Yeah.
won't crash the video.
Got it.
So only like the
Sean says that they can still hear us. Oh, I see us. We're back.
yeah. Slowly. Now I have
Wonderful.
to go into. Oh, what was the room name? Can you send me the room name via Telegram or something,
Oh yes. Can I
Or-
do it
or in Signal, or
via?
You can do it in the
Can I do
chat
it via
too.
this?
don't do it in
Yeah,
the
like
chat
the
here.
chat of the.
Not
Oh no,
here.
because she has
No.
to open it. It's true. No, I got you. I got it.
No, I mean the chat of the of our Google.
No,
Chat.
no, don't do it
No,
there.
no, because she has to
It's
open
going
it
to
on the
yeah, exactly. So it's gonna
You're right,
open up.
okay. Got it.
web. Let me get
Maybe
I'm in.
maybe we can share the link at the end, and then people can just
Yeah,
tune in. And...
at the
Yeah.
end for
Here,
sure.
I just
But
sent
I
it to
figured.
you.
Okay, thank you so much. I didn't want it to do it right now. Okay.
I'm gonna
Yeah,
finish.
Sean
writing.
says that'll help with the context crashing if you put it in a different browser.
Yeah, I want to know. I also have to fix that in Shader Place. I'm thinking about just like switching, like not using Three.js. I feel like that would help. I don't know why. Because
maybe
there's
like
a lot of stuff in
what is it
Three.js I'm not
called?
using.
Maybe
Are you
it's
gonna do
enough with this
pure-
OpenGL. What is it called? This other like lightweight library with some WebGL. I think it's called
There's
OpenGL.
OGL.
OGL, pardon me. Yeah, maybe that's
it's
enough.
definitely lighter. Have you heard of OGL, Char?
I haven't.
Oh,
It's this thing. I was thinking about using this thing called like Rev or something with an R.
is that a light weight? Like, is it like lighter
Yeah,
than
it's like
3S?
just like WebGL. I was also like, why don't I just use WebGL? Another thing.
You should check out OpenGL because that's super. I heard it like from other devs
OGL
working
is
with
here. I'll
with
send it to
WebGL
you.
that is like much lightweight. If you don't need a lot of the
Where's
stuff from
the chat?
3S, like, I mean,
Yeah.
you're only using 3S to kind of read the fragment shader. Is that the only?
Exactly. Yeah, that's literally. the
Oh,
only thing
then
it's
Here,
doing.
I'll send it to you on Instagram so you can see. Whoop.
yeah.
Um,
So definitely, I think you can do either like pure WebGL or just like something much
yeah,
lightweight.
here, it's this.
That's
It's like a
3S.
teeny tiny, very basic, minimal WebGL library.
Oh my God! Someone said, was it last time Char was on? Someone guessed the room name. Yeah, someone like
Yeah.
came in.
Yeah,
Which is like, they were
that's
really
why
nice
we don't
about
want to
it.
share it.
They like I think they like messaged me and were like, sorry, I didn't like think about like what the
Yeah.
what like the questions would be. It's like it's okay. We just like strangers on the internet. You never know.
Yeah.
Okay, now
They
we're
were,
there.
they were like really nice about it. Like they were just like being a hacker, but
Yeah,
like
yeah,
a good,
yeah.
like, curious.
Okay, we're there. And by the way, I see now that I'm in Firefox. That probably when we make the pull request, we need to fix that for you, Char. Like the scrolling bar is in the middle of the screen.
Oh yeah, you're right. I forgot about that. Firefox. Oh well, that's okay.
Yeah, for me in
Yeah.
Chrome though as well.
I couldn't see it for me because it was transparent in Chrome somehow.
Yeah, it's transparent, but I see the outline. But it's fine. I don't kind of bother.
Yeah.
Okay, so wait, let's re
What happened? Now everything
Refocus.
is green.
Really?
Yeah. Did you move something?
For me, it's not green.
Oh, okay.
You have just a green screen?
No. Like the green background and the sphere is white and the mountain is white. Is that how it is for you?
Yes.
Ah, okay.
Yes.
Yeah.
Ah, all right.
Yeah.
Great.
We're where we're supposed to be, I think.
Okay.
So, okay. And then finally, the only thing that I just typed in
Mm-hmm.
without explaining it was this last part of the direction.
Ah, the
The
FOV.
fog.
Yeah, the
Field of view.
FOV. So you can change the FOV here. We can make this like 1.
Mm-hmm.
Like, what would that look like? Same. What if it's 10? Wait, what? What's happening here? Is this not updating for you?
I think it's not updating.
No, nothing is happening. I mean, I don't see the difference. Do you? Oh, I see the difference now.
Oh, now it's gone.
Now I see.
Okay.
Yeah, exactly.
Sorry, I was
it's like
just testing
pushed
it.
down somehow.
I'm trying to figure out why this isn't affecting it.
Like
Oh,
the
because we
fog?
haven't used it yet.
Yeah, we haven't used it.
Got it. I was like, what?
I have a
do that
question.
all the time.
Why do you? Oh no! Wait a second. I think I understand, but for the people that is watching, you are multiplying the z-axis, like the y-axis and the x-axis get multiplied by the UV, but the z-axis get multiplied by the fog because it's our field of view, kind of like this other number, right? That we want
Yeah.
to, like, for people that is watching.
It's like, yeah, it's like how much
Yeah.
like are we taking into account? Like
Yeah.
if there's a lot of field of view, then there's like everything gets really small and it's kind of like using like a bigger lens, and then
Right.
I mean your field of view is smaller
Yeah.
and bigger.
Yeah. Cool. All right. Yeah.
Yeah. I'm honestly a little over. I'm just looking at the chat right now. I'm a little overwhelmed with all the choices that I have of like replacing through JS.
Ah, okay. Yeah.
I mean,
I am
yeah.
sure,
I'll make, like,
you
a
know
research
what?
document.
Leah, who was here, I don't know if she's still here.
Are you
She
still here,
writes,
Leah?
I think she writes some of her shaders on CodePen with pure WebGL, because basically she's just reading the fragment in HTML to like render, right? So I think she just writes pure WebGL. So something like that should be definitely like improve the performance on shader play. So we should definitely take a look on that. Like,
Yeah.
Yay. Yeah, that would be really cool. Then
Yeah.
we can do more streams. Okay, so that now we have our lookAt function. It takes in UV, camera origin, and camera target. I'm just gonna copy it and paste it under. So instead of ray direction, instead of this like very simple ray direction, we can just put in this UV, camera origin, and cam target. We have to define the camera target.
Okay.
wait, where are
And
you?
that's
I need to scroll
She's
down.
on line
Sorry,
80.
80. Yeah, sorry. I just kind of jumped ahead. I'm getting better at that, but I still do it sometimes.
No, I just need to know because I need to show it in the stream. That's
No,
why I always
you're
have.
100%. Yeah, 100%. That's a teacher thing that I need to like do. So
right.
we need to define our camera target. So vec3 cam target. Let's just do vec3, and then let's have it move like back and forth. Let's have it look.
With sign. Okay.
And then I think I defined time. Yes, time
Yes,
of that, and then
we
let's
have
have
it
it
somewhere
be
there. Yeah.
0, and then let's make it 1. You look around like that, and it's mad. Why is it mad?
Because the ray
I think you need a dot after your O.
Oh no, it's
No.
because I called it camera origin. It should be camera position.
Oh, there it is. Okay, so right now, in
Wow.
reality,
We
what's
see.
moving isn't the object, it's
Yeah.
the screen. That's pretty
Indeed.
trippy. I
Yeah.
love it.
Like the camera, basically. So.
Yeah, the camera's like looking back and forth. And then
Yeah.
so if we change the FOV now, make the wait, oh my God, it's still not changing.
Yeah, it's not changing.
What?
Why?
But okay, so the camera moves and it takes the screen with it, right?
Yeah,
Yeah.
exactly.
Yeah.
Yeah, I think
Yeah.
it's maybe because the circle just like isn't interesting enough for it to like depict any changes.
And I have a question because probably I missed that when I was like setting up Firefox. Like, where is lookAt being implemented?
lookAt is right above main.
Yeah, but where are we implementing it?
We are using it on line. Oh my gosh.
That's
Where
a good
is it?
call. Good catch.
What?
Yeah.
Oh my
Because
God.
How
we're
is it
not using it,
working?
aren't we? I don't think
I
we're
You're right,
guess
we're
because
not
of the
looking at it.
UV.
I
This
think
makes
That's
more
crazy
sense to
that
me.
worked. How did that work?
yeah.
Because
Can you go back
don't
to see
work.
how that worked? Can you go back as
I just deleted it. I just put UV, comma, camera position. Oh, maybe the ray direction was UV?
Because
No,
because of the cam target. 'Cause
it's
you've
the
got
cam target that
in
you
there and
add
there's
the
a
sign. Yeah, exactly. So I
You've
think you
added
were
it.
what
just
what
you,
the hell is this?
the right direction, the right direction.
I know, but like,
But
there's
like,
nothing. It's just
it's true. There's no
parentheses.
plus or minus or
Okay,
multiplication.
yeah,
It's
yeah,
literally
you're
just a
true.
Parentheses and
statement.
it's holding thing.
Wait, so if you just put ray direction equals cam target, is it the same? I guess it
Oh.
controls for like
Maybe it's
whatever.
the way that it's reading the error. Like it's just like reads that somehow.
What if it's just UV then?
Maybe it's
It
just the
still
way
works.
of reading the error.
No, it
Or what?
errored here. That was an error.
Ah, okay. And then it says.
But
So I
it
think it
still
was just
shows.
target. I think it's like the same way
funny.
that people use like a single line to declare things. Okay, so now
Yeah.
we can choose the FOV and it
But
should
anyway,
change.
yeah.
Thank you,
This should-
Olivia.
Yeah.
Yeah, I was
okay.
just
Finally.
Makes more sense.
I was a bit confused because I was like, how are we using the lookAt without implementing it?
Oh my gosh, Olivia,
It wouldn't
you're so
have worked
good.
if we hadn't put the time in. We wouldn't have seen it.
Yeah, yeah. But I was confused
Okay.
because it was moving. But now definitely we see the difference of the fob. Yeah. So if
That's
you put
awesome.
something super big, like 10, did you try 10 or what were you trying before? A super small number, right? So,
10 brings
yeah.
it super close.
and then
Okay.
if we want to be far away, like a small number, like a floating number. Cool.
Do we want to?
Amazing. That looks like a road and then something behind the road.
Yeah. I love the
Yes.
perspective.
Yeah.
Do we want to zhuzh it up with some color quickly?
I agree.
Yeah.
know.
Yeah. Now it's time
Should we
to
just
bring
go
that.
like willy-nilly, just like that?
Yeah.
Yeah.
I'm gonna
yeah.
make it also
Just
so
bring
that,
the
like-
color palette.
Oh,
Oh yeah.
yes.
Where?
Because
is
you
that?
wanted
Let me-
to bring the color palette, right? So now that I'm thinking too, were you teaching this lookAt function in your workshops, Char?
Oh, that's such a cool movement.
Because
I'm into
I
it.
feel
I
that
love it.
I've seen it in your code before. So maybe you were teaching
Indeed.
this before, but it was
Exactly,
when
yeah. I
for
used to
me
teach this.
I couldn't understand anything that you were
Exactly,
saying. I
yeah.
was just like, so
I
probably.
realized that like this was not a good thing to teach the first time that you teach someone raymarching, and so
Ah,
I got rid of it. I don't teach it anymore.
Because I think when
Yeah.
Eliza and I were like last summer, you taught us this. I feel like I've seen this lookAt function before, but probably I didn't get what it was back then. So
Yay, but now we're here.
yeah,
Yeah.
exactly. Now it makes so much sense, and I'm so happy to hear this.
Where is cosPallett? I'm on Inigo's
have a
website.
question,
I can't
though.
find
Oh,
it.
I
We
have
could-
it open right here. I
Oh,
should.
okay.
We could
Yeah.
use the uniform of the mouse to move this lookAt.
I
Yeah.
actually
Let's
don't think
do
that,
that,
I
or-
have. I don't think I might have not put that in yet. That-
Because I saw it in
No, we can
line
try it.
8. In line 8, you have the uniform, you mouse.
But you have mouse, yeah.
Yeah.
I don't know if I implemented that on Shader Places side, so like the JavaScript side.
Okay.
Got it.
Okay. Because that
Okay.
would be
We could try it,
interesting
though. I mean,
to put it
wait,
and
let
then
me
like
see.
to move around, right? So
Yeah.
Let's see.
is that a vector 2?
Back to.
Oh, I put in cosPallett function. If you see at the top,
All right. Where? Yeah.
the very very top.
Cool.
And I'm just gonna copy and paste some like numbers. Is that okay?
Yeah.
Yeah.
Okay.
Okay, I put the mouse in, but I don't think that it picks it up.
Yeah.
No,
I'm sorry.
it's not picking it up.
That's
All
being
good. All good.
Another issue.
Yeah, don't worry.
Okay.
Yeah, because I'm like starting to just realize I'm like, oh, other people besides me are gonna use this.
Well, that was your intention, no? Or no?
It is. It was my
Was
intention.
it more
Yes.
like maybe now that I'm thinking, maybe you did it like Patricio said once that he did like the cards and his projects for himself, and then it turns out that
Yeah.
people like them. So maybe you did this for yourself, and then it turns out that we like it, so
Yay.
we could use it.
Yes.
I love the
I would love
movement of
that.
this. So,
Where
Oh,
you
I'm actually
are-
gonna put this in the.
Maybe
I'm
in
gonna move this to the
in the trays, no? So or
in the trace exactly. Yeah.
'cause it makes more sense, I think.
Yeah. And then instead of this vector 4, I'm going to define background color up here, and then I'm going to return background color.
Yeah.
BG. I'm just going to call it BG.
Mm-hmm.
And then here and here, we'll just do BG.
Yeah,
Cool.
that's how we do it. Oh, it keeps, I don't know. Ah, okay. My screen
Okay.
kept scrolling down all the time, but I realized that it's because if I don't move myself close to
Yeah, you
where
have to
you
go up,
are, yeah,
or
then
else
it,
it'll go back to you.
yeah, exactly. I'll be back in a second.
Yes. Oh, it's all black now. So BG right now is undefined. And so I'm going to define BG. After I define my total distance, I'm just going to redefine it to be like your total dist. And then contrast, oscillation,
Oh,
and
cool. To
phase.
distance. I love it. Yeah.
And now, cosine_palette returns a vector 3. I'm going to change it such that it returns a vector 4 just because I'm too lazy to change that elsewhere. So just have this be 1 at the end. Oh,
Yay!
There we go.
Rainbow.
too psychedelic.
It looks like a
Just slow it
tunnel, in
down.
fact.
It does. It kind of looks like
Like a
yeah,
tunnel,
we're
and then
in
you
a
have the
tunnel.
street. If
It's
we
Yeah,
keep
right?
that gray.
appropriate. Colors are definitely
Yeah.
on point for the experience.
Yay.
That's awesome.
Yay.
I fuck up something when I was trying to separate it.
That's a-okay. It's very...
Cool.
What else should we do? I'm going to add... Should I start adding shapes? Should I do like a...
Yeah.
Maybe I'll do like a... I'm just going to start like copy and pasting in like different functions, if that's cool with
Yeah.
Yeah,
you.
totally. Can I maybe, where's the floor again? Or the floor is part of the...
Of the scene.
Yeah.
So I want
Right
to
here.
add color to the ground.
Yeah.
How
Go ahead.
do that? Ground
So
is
instead
part
of... So that's where you... So this 57.
Yeah.
You could add color to that, but it would also add color to the circle because right now they're
To everything that
just
you have in the
same.
scene.
Yeah, we
Exactly.
would have to like
Separate them.
separate them. Yeah,
Yeah.
which would be a
Into
little
two
bit of
different
work.
things and then add them together.
Yeah.
But you can
Got it.
color them if you want. To change them
I
instead.
might. So I do that in line above line 57. Wait, what? Ooh. Oh.
Sorry, I removed
there's
the
a
floor. I removed
Okay.
them. I was just testing here.
So
Oh, I like that. You see a road, kind of like.
if I create a color within the if dist is less than epsilon, and then I add it to like what's between the brackets, that's going to color the mountain, the floor, and the...
And this, yes, exactly.
Okay. I'm just going to test something silly then. It has to be a vec 4, right? Yeah, okay. It's probably going to end up being brown because it's always inevitably what you end
Yeah.
up with somehow. It's not on purpose. You add color?
I'm gonna use modPolar. I'm just gonna copy and paste this in, and then I'm gonna offset the circle and then do like a circle modPolar. Maybe it'll be like a nod to your last stream.
Yeah.
Yeah.
Awesome. Okay.
Polar coordinates.
Maybe I'll do a little mix. I'll make it a little mix.
I like it. It's pink.
Yeah.
Yes.
It's a nod to you. Let me add a yellow since it's wait, what's yellow again? Red and green, no? Oh, I'm so rusty. Like for combo mix. I'm rusty with my color theory. Call to combo. Make any sense? It does not seem to be working. Oh. Why do I have an error?
I'm also
Char is
uh,
changing stuff as well.
yeah,
Oh.
yeah, sorry, XY. There we go. Okay, I'm compiling now. Are you compiling?
She has an error, but
Wait, why is a mix is a vec? I'm confused. Oh wait, it's a flow. My bad. Mix is a flow, right?
Mm-hmm. It depends. I think mix might be overloaded.
Ah. Flow, syntax error. Flow, mix.
I think because this needs to be
I
a
get-
vector 4, no? Why
Yeah, it
did
has
you
to be a
change
vector
it?
4 because I'm adding 2 vectors. Yeah, that
'Cause
should
it's
make sense though.
two vectors 4, so
Yeah. But then, yeah, okay, so that was right.
I'm also
Thank you.
not compiling anymore. I decided to
and
do
then I get an
something,
error.
do another thing.
okay.
But so then, how does mix work as a vec 4?
The same. No, you don't. Mix would always have 3 parameters. Eliza.
Right? But then
Yeah.
that's what I mean. So I have,
But if
then
you're
I
like-
still get an error.
but
It
if
says I
you're
have a
lose-
syntax error.
If you have like a vector 3 or a
this be a
float,
vector
you need
four?
the second parameter to be the same.
Oh, wow.
Is that it?
And then
Yes, sorry. Completely.
Wait, but it's still not compiling.
no,
Hold on.
it's still not
Still not
compiling.
syntax error. What am I
So
doing wrong?
maybe in the vector 4 up there. Hold on.
Vec 4, vec 4.
Oh, there's a
there's
a
a
semicolon.
semicolon missing. Sorry,
Yeah.
guys.
Whoa,
What?
sick.
Because
That's
I believe,
awesome.
let me check the
That's not me,
interpolation.
though.
Yeah, that's not you, that's Char. I
That's
think the
something else. Okay.
interpolation could have been just a floating number. Yeah,
I thought so,
that's
but
what
I got an
thought,
error
yeah.
when I did that.
Yeah, because you had an error above. It was not that.
Oh, right. So right.
Because the
Okay,
way
cool.
that mix function is that the first 2 parameters have to be the same, but then third one, I
Oh,
think
shit,
it can
my
be
computer
like
screen.
whatever.
Okay.
I really like the psychedelic roof in the tunnel now.
Yeah.
It
Oh,
looks
that's
like
very
a
fast.
like
Sorry.
a fun
Wow,
house.
these are great
or-
colors. What?
Why is my computer screen? Shoot. No.
Where are
we go.
you,
Okay.
Char? Ah, you added the module
There we go. That's
polar.
a little bit
Did
nicer.
you
Yeah,
write the
just-
modPolar function, Char?
What?
Did you write this modPolar function?
No.
Oh,
I
okay.
got that. I should put the credit above it.
Okay.
This is
I
from
was just
Mercury.
wondering. Mercury. Okay, cool.
Wait, where? What
Mercury.
modpolar? Oh, modpolar. Okay.
Yeah.
I'll link it too. I'll link it for people because this is a great resource.
Yeah. I was just curious. Yeah.
Mercury.sexy/HGSDF. I'll put it in the chat.
Mercury, that's sexy.
I'm into
Yes.
these colors though, and I kind of love the fractured ceiling,
Yay.
fractured
cool.
sky. It's very cool. Oh wait, is this what we? I think we modpolar. Did we use this in one of your workshops? I think we did this
I
in the
feel
audio
that
reactive
maybe.
workshop.
Yes.
don't
yes,
remember,
that makes
maybe.
sense.
I do remember. I was so impressed with it. I love this thing. Cool. Oh, I have it
Oh.
bookmarked. Yes. Already.
That's a sexy website indeed. We love it. Wait, so there's someone rating here.
Really?
Yeah,
I don't see it.
with a party of 28. So now we have
What?
50 people.
Oh, okay. Who did
wow.
that? Thank you so much. Who
Thanks,
has been
guys.
rating
Aw.
us? Thank you so much for bringing newbies.
Thank
Hello
you.
and welcome.
Pablo
to
makes
everybody
is rating.
who just
Welcome. We're coding shaders.
We're making shaders. Yeah.
I love this ceiling so much. The
Psychedelic-
sky is
psychedelic
tripping me out.
Yeah, me
You think
too.
we should get rid of the? Oh wait, no, we don't want.
Of the floor?
I really love
No,
this
I
sky.
like the floor because it still looks like
Yeah, I
you're
like the
on a
floor too. It
path.
gives you like context. Yes.
Yeah, like you feel like maybe not a tunnel, but just you're walking something. And this is looking very like 70s too. Like
Oh, I
Yeah.
really like it.
I
Yeah,
wonder
it's
why
psychedelic.
it's like a little offset. Like we're not in the center.
it's not
of
in the
screen for
center.
some reason, which is really
Yeah.
weird.
Mm,
I think maybe that's Andrew's and my fault when we did the pull request. That
Oh,
maybe
really?
I feel that maybe that's our fault because I see the scroll bar in the middle. So maybe we didn't like, I don't know. It could be because the scroll bar is in the middle of the screen too, So maybe that's why we don't
so
see
maybe
anything.
everything got. Is it a
So it's
CSS?
push.
No, it's not a CSS.
Yeah, it's a CSS. I have the feeling that it's the CSS that we.
Ah, it is.
like,
Okay.
Oh,
So we
that's
push
okay.
everything like a little
It's
bit like this.
working.
Yeah.
Yeah, maybe we'll just do like a UV norm chord
'Cause-
plus.
Because do you see the scroll bar where it is like in the middle of the screen?
Yeah.
Do you see it as well, Char? The scroll bar
Yeah.
that it's okay, and then
Oh,
think about the
wrong way.
center from there. Like from the edge of your screen to
Yeah.
the scroll bar,
Okay.
it was center before.
So
So
let's try 3. 2. Yeah. Hey, now we're centered.
Nice. That looks
Yeah.
good.
Cool.
I kind of like it that it's like off edge.
Yeah, it's kind
I
of like
really-
an album artwork. Like it's gonna be like featuring,
Yeah.
like the words.
It reminds me, this is going to be really weird, ref, but this reminds me of the song from the opening theme of BoJack somehow. You know what I mean?
Who?
Does anyone watch BoJack?
No, I
Kinda
don't
gives me
even
that
know who
vibe.
BoJack is.
BoJack? You've never watched BoJack? No.
I don't know.
It's
Oh,
on
the
Netflix.
horse
I mean,
thing, the horse
yeah,
animation.
it's kind of depressing, so you have to be in the right mood, but it's pretty funny. I mean, I love the opening theme song.
watching that show like 3 times because I had a good friend who likes it a lot, and I've tried it, but I don't get it. Like I watch one and I'm like not hooked, you know.
You mean it's a depressed horse? It's like it really takes. Yeah, you need to be in the right mood.
Yeah.
Do you like Rick and
probably.
Morty?
No, I don't think I ever
Ooh,
watched
I
that.
love that.
So
Really? Okay, so I feel like if you're not into Rick and Morty, you probably won't love BoJack.
mm,
The background is I'm into
I really
it.
like it. Yeah.
So
me too.
this effect you
I
did
love
with the modPolar, right?
modPolar. Yeah.
You
You did it right.
modPolar actually isn't doing anything. I just realized.
Oh, so
What?
wait, yes,
Because-
it is.
Are
I
we-
changed-
No, this mod position is not modPolar. I have to assign it. I thought that this was an in-out vector, but I realized I changed it for my students because they get confused by that.
Ah.
Okay, now this is using modPolar, and
Ooh, it's
But-
got a little pinch in the center, but in the back there. I like it.
Can I do like something just to see what was
course.
doing that? So just
Oh,
okay.
cute.
So it was the
Okay.
modPolar indeed. So like the whole like craziness. If I commented.
So wait,
yeah,
what does
so-
modPolar do?
No, wait. The modPolar is breaking first those rays here.
Super cute effect. And then if you modulo position,
Modulo
once-
was making the circles kind of
'cause then you're
fractally.
subdividing.
Yeah.
That's really nice layering of
Mm.
stuff, of effects.
I'm gonna move
Wow.
it around just to see what it
Yeah,
does because
yeah.
I really want to create like more kaleidoscopy looking. I don't know why.
What?
like,
Where do you want to
currently-
create?
More
I just wanna make it
kaleidoscope
look
vibes.
like kaleidoscope
You know?
vibes. Yeah.
The optical illusion stuff that we love. You know when you look through a thing, Elisa, and
Ah,
you turn it? and
okay, yeah. Okay, that's called that. Okay.
What's it called in Spanish?
Actually, I cannot think. I don't remember.
Well,
I
you know
don't
we're talking about
remember.
the toy.
Yes.
Yeah.
It's one of those things that if I hear it, I'm gonna be like yes, but I just on top of my mind.
Yeah.
I don't use Spanish
okay.
too much, so it's sad that I forget some words.
No, that's okay. That happens to me a lot in English and in French and in every language I speak.
Yeah, it's just speaking 3
Oh,
languages.
okay. So
every day.
SciCode says it's a kaleidoscopio.
Yeah, right.
Kaleidoscopio.
Kaleidoscopio. Thank you.
In
Yeah,
Portuguese.
I haven't.
so it's the same.
In Spanish, it's the same. Kaleidoscopio. Yeah. Cool. Thank
And
you.
Sean says he loves Rick and Morty too. Well, BoJack is like Rick and Morty, but like slightly more depressing. It's about an alcoholic horse, but it's funny. I don't know. It was funny anyways when I watched it at the beginning of COVID. I don't know if that still holds.
I heard from other people
shoot.
like you that they like this show.
My camera just shut off.
I
after
really
my
like
face
that
froze in a
effect.
really ugly.
Do you know
Let's see
how
if that
what it reminds me too? This fractal kaleidoscope thing, like when you go to this what is it called? Is it called glass house in English? When you go to these
Oh, a
fairs
mirror room.
and you enter and you have maybe mirror and
All the mirrors.
yeah,
that are facing
exactly.
you.
Yeah. And then you see all of
I love
these
those
shapes,
things.
and you have to find the exit. So it kind of reminds me of that too.
Ooh, my background is not blurred anymore. You can all see my bedroom.
I know. Same thing
Yeah.
happened to me, and now it won't let me like apply it.
Shoot,
I'm, like,
well,
in the
my room
middle
is
of
relatively
moving,
clean, so
too.
it's fine.
Yeah.
It's fine. You're like, I think it's totally fine.
All right, we're
I
all
really
good.
love
So yeah,
this
kaleidoscopes and
psychedelic.
mirror rooms, and
Yeah.
I'm just into the shards and the movement. It works well
Mm.
together. I like it.
Yeah, I love it.
Funhouse, Sean says. It's also called
Yes,
Funhouse.
funhouse. That was the word that I
converted.
had in my brain, like a funhouse. Yeah, make me think
They
of
kind of,
this
I
like.
was always scared to go into an actual funhouse.
Yeah, I was
because
just
it's like,
gonna.
it's not just mirrors.
I just was
There's
gonna mention
clowns and
that.
shit in.
It
Oh my gosh,
reminds
yeah,
me.
we
It
know.
reminds me those like horror films from like the early
Yeah.
90s or 80s, like
Yeah.
with like it was. I think there was one called Funhouse, and then you go to this theme
Probably.
park and you go
Yeah.
inside and you find clouds and all this stuff.
And they run after you, and there's always really creepy music.
Yes.
No. The mirror room, no, it's called the infinity room, what I'm thinking of, where you walk in and there's like lights and you see many mirrors, but it's pretty. It's not scary. There's no
Yeah,
clowns.
maybe.
And it's usually more at like a gallery or a museum than a circus. Circuses are freaky.
Yeah.
Char's
I
very
agree.
concentrated.
Yeah, I think so.
Yeah.
You're doing
Sorry.
something. I actually lost you. I don't know where you are.
Where's
Where are
your
you?
cursor?
Yeah, I don't find
Oh,
you.
I haven't been doing anything. Well, not really. I've been just kind of like
Okay.
noodling around with the position and
Ah, okay.
Cool.
Yeah, because I
in
keep
this. I think I'm
seeing.
in the scene function.
Ah, true. No, I see you now. I think you're
I lost
in
both
the
of your
trays.
cursors. Oh,
Yeah,
no, I
me
see
too.
you.
I'm highlighting the scene function
There you
right
go.
now.
Okay, cool. What if you were to swap? I'm gonna do something weird. What if you swap Y and X? Does that change anything?
I
Yay!
already did that and I didn't see too much change.
Hmm.
Like,
Mm.
We could do a YZ, see what happens.
Mm.
yeah, I tried that,
Mm.
but oh, with floor.
Mm.
Okay, cool. Yeah.
Mm. That's funny. And a YZ. Cool.
Mm.
There's like a, now it looks like there's an eye.
Yeah.
Kind of.
Yeah.
I mean,
Trying to
before I
see
saw
you.
like different eyes as well, but in this
I really love
fractals,
the colors.
me too.
Yeah. It kind of looks like the turbo palette
True.
a little bit.
Yeah, I forgot about that one. You really like that
Is
one
anyone
too.
here? Is anyone watching colorblind? Can they tell us if they can see the colors? Okay.
I can
The
test
Yayoi Kusama
myself.
room is yes, converted, exactly. I love Yayoi Kusama.
Yeah, I
She's like
think
my
it's
favorite.
okay, Char. I have an app, and it looks fine.
Nice. Oh,
So this is
super.
visible for everybody?
Yeah.
Awesome. Cool.
Yeah, there is a wonderful
Okay.
app called for Mac. I'm gonna tell you the name. It's called Sim Daltonism, and it's pretty sweet because then you can test different color blindness.
Ooh.
Oh,
I use this
wonderful.
when I design stuff because as a designer, you have to make sure when you choose certain color palettes and shapes that different people can still perceive the stuff, right? So let me see if I can find the link. So it's very useful and it's interesting to
What
check
time
out.
is it for you, Char?
It is 3:08.
Have you had lunch yet?
No.
Oh,
Just
But
trying to be
I actually
just
have,
trying to
I
be
didn't
mindful.
even finish my oatmeal. So.
Oh no. Okay, yeah, no, we should go. We've been doing it for 2 hours. I don't want to take up all your
Yeah.
day. It's your Saturday too.
I
So.
took off yesterday and the day before, so I've been like, I
Oh,
feel like
you're
really
having a good week.
rejuvenated.
Okay,
I am. I'm
good.
having a really good week. Yeah.
Good, good, good.
Because I was like, I'm gonna work on Shader Place for those 2 days, and then I just hung out with my friends, which
Is
I
the-
also needed.
Yeah, of course. Most
but it's the
important.
weekend, so
Is your replay up that you did, Char? I don't know if everyone knows this, but Char did a shader tutorial for Looking Glass in which
Oh,
you did it
yeah.
again, right? I missed it because I was in the train coming home from work that day. The first one I was there for, but then your
I
computer
know.
updated.
Yeah.
No.
I know. It was like.
But is the
unfortunate.
replay up? She did it all in HLSL, so it's a different shader.
Yeah. It's like a Unity.
dialect.
Yeah, and I also was like doing it like you don't need to have a Looking Glass with you to like do it.
Cool.
But it's like the tutorial's like for the Looking Glass, but
Yeah.
you could if you could just do it in Unity and like skip all the Looking Glass stuff, so you don't need to necessarily have it. But it's for like writing a like single plane shader in Unity, and then we also modify the vertices. And so
Okay,
it's
I'm
really-
into that. Yeah.
and it's a really like boiled down. I think the line I think the shader itself is like 10 lines of code, and
Wow.
so it's a very like boiled down like here's how you can do this kind of
Okay.
stuff in Unity. So like
Yeah.
if you wanted like this to be like on a picture frame in the wall of like
Yeah.
your character
Yeah.
in your Unity game, like that would be a great tutorial to do that. And I think it is indeed on the Looking Glass Factory's
It's on
Chris-
okay, cool. I'm gonna check it out
Yeah.
because I managed to port based on all of our other work. Like I managed to port a raymarched blob
Yay.
into Looking Glass, but I'm curious to see your version. I'm sure it's cleaner than mine. Mine was very
No,
happy.
it's not. I definitely like. It's nothing impressive either. It's just like not raymarching. It's 2D. It's just like
Something basic
And
as
then-
well, maybe.
yeah. It's
For
really
some people
basic.
that wanted
yeah.
to try it, I imagine. So,
Yeah.
Cool. I'm excited to see it.
yeah. But is there a
Yeah,
replay?
I can-
Because I never understood.
Yeah, it is.
Yeah.
I think
Do you
it's on
have-
Looking Glass.
Do you have the
Factory.
link to share for
Let me
like
see
the
if
people
I
that
can
is
find
watching?
it. On the YouTube of Looking Glass now?
Oh, it's on Twitch.
Oh, on Twitch still. Okay.
Oh, even better for like to
Twitch.
share it on Twitch. On Twitch.
Yeah.
I think it's like the only thing on our Twitch channel. Yeah, it's the only thing.
Oh,
Okay. Yeah,
cool.
because there's
There we
another
go.
one coming up on Blender, I think, but it's really late.
Yeah,
so I'm gonna have
Brian.
to watch that.
Yeah.
Brian's so great.
Yeah.
Looking Glass.
I'm gonna put you on the
Anything?
screen for a second.
Oh, I put it in. I
Oh,
put it
thank
in
you.
the chat.
Thank you. Okay. Do you have anything coming up that you want to talk about? I don't know. More
Oh.
performances. You've been doing so many performances.
I do. I have 2 performances
question.
coming up. One of them has been announced, and I can link to it. Gosh, what is it called again? It's like a queer hacker party.
Cool.
It's really exciting.
When is it happening?
It is happening January, so it's in a while.
Okay. Is
It's
gonna be
hosted by Tech Learning Collective, and it's called s02e2 Cold Boot. It's like the aesthetic is kind of like, you'll see. It's a little bit like, oh my gosh, like of course this is what it was. There's like a bunch of like hex numbers in the background, but I think it'll be really cool. I mean, like I think it'll be cool in that like
Oh yeah.
it's like a queer hacker space, and I've actually don't think I've ever been in a hacker space that's like dedicated for just queer people. So I'm like really
Yeah.
excited
Awesome.
to.
In Brooklyn. Cool.
I'm gonna
At
put it on the
Wonderville.
screen. Maybe a little bit late, but I just put it on the screen for people that is watching the party on January.
Awesome.
Yeah.
And
And then I have another performance also at Wonderville on December 17th. We haven't like published it yet because I've been slow with the poster. But
is it going to be streamed at the same time, or it's all in person?
I don't think we have the capabilities for streaming. I mean, I could ask, but I don't think.
So these are live events, live performance.
so if you're
in
for
New
people in
York,
New York.
Come
Yeah, if you're in
through.
Brooklyn, yeah.
If you're in Brooklyn.
Do I have
come through.
anything else coming up? I think that's it. I think
Any
the next
workshops or any
performance-
classes that are you giving before the end of the year or at the moment?
No.
Okay.
I should, but right now I'm like full-time work.
Okay, yeah,
Yeah.
of course. That's
If
that's
enough
why I asked.
people bother me, I might do it.
No, but it's good to take some breaks. and
I
stuff,
think so
too.
too. Yeah, especially
Like I
if you
feel like
have
if you're in a
full-time job.
performance mode, you gotta milk that because you're so good at that stuff, and I think you enjoy it a lot. Probably gives you energy in a different way than teaching now.
Yeah, definitely like I need to like fill the cup here, and then I gotta go back and fill the cup there and
Yeah.
stuff like that. And also like when I'm done
Multiple
moving,
cups.
like
Yeah. Oh, and
Yeah,
you're
like-
moving. It's true. I
yeah,
saw
I'm
that.
like moving. So
That's a lot. Yeah.
do I use
Cool.
Shader Place for performances? I do not. And
You
maybe
use the
one day I
Force?
will.
Or you use the Force, right?
Use
So-
Code Life, no?
I use CodeLife, yeah.
Yeah.
Ah,
Sometimes
okay.
I use the Force. Mostly I use CodeLife.
Okay.
Yeah.
Hmm.
Yeah, because CodeLife it gives you like really easy ways to get like MIDI input, which like is great to have if you're doing visuals. Like
Yeah.
you just press a bunch of buttons and
Yeah.
you hook it up to functions. And
Yeah.
Shader Place is not there yet. Shader Place is for teaching,
Yeah.
maybe eventually for performing, but
Hmm.
not right now.
Awesome. Well,
Yeah.
I don't want to steal you for much longer because I feel like
I know, yeah, because
a
it's also
lot.
late for y'all.
Yeah.
it is 9. Yeah, it's 9. I want to make
Yeah.
some dinner too.
Yeah, me
But-
too.
It's okay. I've been in Spain for the last week. I'm on Spanish time now. It's all good. I can eat at 10 and it's fine.
Oh, but it was
but yeah,
great.
thank you everyone for coming.
Yeah.
It's so
This
lovely
was
to have
so
you
much
with
fun.
us. Yeah.
Yeah, thank you so much, Char, for coming up again to the stream. And
Yay!
yeah, we're
Anytime.
welcoming
this
again
stream.
if you want to come back for a third
Anytime.
time in the future.
I love this stream so much. At the end of all my workshops, I now pitch it. I tell people to
thank
watch
thank
the
you so
stream.
That's so
Yeah,
sweet.
yeah.
That's
Because it's
awesome.
like it's so wonderful for students to see, like, for if they learn this, they see like applications of it and like different people digesting it in different ways, and it's just amazing.
Yeah.
That's awesome. Thank you so much.
Yeah. And we learn with you, so you can also
Yeah.
pitch that these are my
The stream would not exist if not
previous,
for you, Char.
yeah,
So.
because we were your previous students
Aw.
like last year.
What's the thing that people do now?
Aw, yeah.
What
Cool.
is
All right,
that?
well,
That
thank
I
you,
didn't like a
everybody,
little
for-
heart?
It's a little heart.
Like
yeah,
a little
exactly.
heart.
It's a little-
I imagine like, okay, that I didn't know.
Yeah.
Learning.
Awesome.
Then thank you
Should we-
everybody for being here today.